Think about it. Think about it.
Kick.
Think about it. 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 Think about it.
back to my heart. Didn't mean to hurt you bad, only did those things so that I can make a little room for us. I wish on every shooting star that you still come back to my heart. On every shooting star that you still come back to my heart. Can you see how we've come so far? Hope you still come back to my heart. Didn't mean to hurt you bad, only did those things so that I can make a little room for us. I wish on every shooting star that you still come back to my heart.
Ladies and gentlemen, please join me in welcoming to the stage your MC for Serverless in the Park, Anjana Vakil.
You know we're here. We're at Serverless in the Park. I'm Anjana. What's up, y'all? I'm gonna be your MC today. We have so much good stuff coming up. Who's been to the last couple of days of Reactathon? Yeah, woo! So you know the drill. You know we're here. We have amazing speakers lined up for you today. We have other fun stuff going on. We have delicious food and snacks. We have some fun prizes. There's lots happening. But today we are officially at Serverless in the Park. Woo! Which is sort of part 2 of the conference we are unofficially calling Developer Coachella. And so, yeah, we are really excited to be back in person. If it is anybody's first day joining us, welcome! Welcome to the beautiful amphitheater we find ourselves in the gorgeous, golden, rolling East Bay Hills. So we have an amazing program for the next few days. For today, of the last few days, we've had amazing talks. Today, we have our final day of talks for serverless is our focus of the day. And we are just really excited to be here and want to thank everybody that's making it possible for us to be gathering in 3 dimensions in this beautiful venue. So first of all, thank you so much, Cal Shakes, for having us here at this gorgeous theater. You can check out calshakes.org if you want to check out their theater program and awesome productions you can come see. And also, if you or your company is interested in hosting an event in the Bay Area and want to have the most gorgeous venue ever, you can talk to the Cal Shakes staff. You can go find John and Kyle at the Cal Shakes booth first thing on your way out of the venue. And we also want to follow Cal Shakes' lead in acknowledging that today we are gathering on the ancestral, occupied, and unceded lands of the Bay Miwok people and the Chochenyo-speaking Ohlone people. And these lands were taken and colonized violently. So please also visit calshakes.org to learn more about how you can contribute to the Ohlone community's work in making sure that we have a vibrant future in these lands for many generations to come. Okay, so we also have to thank our amazing sponsors for helping us be here today. So our presenting sponsor this year is Vercel. Woo! Vercel! Yeah, they do stuff that developers love because they are making the web faster and providing these front-end toolkits that are so amazing. So really unlocking our potential as developers, right? And helping us build the future of the web. They're the creators of Next.js. We know it. We love it. Am I right? they're the creators of other open source libraries like Turbo Repo, Webpack, SWR, SWC, so many more. I can't even say them all. They got a booth out there. Go hang out with them. They're lovely people. And if you missed any of the talks from the Vercel team earlier in our program, you can check out the recordings. And we also have, as a platinum sponsor this year, I'm going to try not to be too biased because I work there, but please join me in thanking Hasura, who is sponsoring as well this year. Yeah, thank you. A little love for Hasura. So in case you don't know Hasura, we give you instant GraphQL for your new or existing applications. Essentially let you connect to your databases, connect to your APIs, other people's APIs, REST, GraphQL, whatever you need, and pull it together into an instant, real-time, unified GraphQL API. I think it's pretty cool. Other developers think it's pretty cool. It does not require any previous knowledge of GraphQL. You can take it from me, and it's built on open source. So check it out, Hasura.io. We also got some of my amazing teammates at the booth over there. Come say hi. Okie dokie. So, as we know, it's been a rough couple of years. We haven't been able to do things like this and look each other in the eyes as opposed to the Zoom squares. So very excited to be able to gather in person. But in order to make sure we all have a lovely, safe, pleasant experience, we have a couple of housekeeping points to keep in mind. First of all, code of conduct. It is up on reactathon.com/conduct. We hopefully have read it. We also want to be welcoming to one another, and that's where the Pac-Man Rule comes in. Who's been doing the Pac-Man Rule? I saw it yesterday. Yes, thank you all. If you haven't heard of the Pac-Man Rule, this is where, okay, you're excited about a conference talk you just saw. You're standing around with other people. You're in a circle. You're really excited about the conversation, but nobody else can get in to join your conversation because it's a circle. However, if you turn that circle into a Pac-Man, open up a little spot so a new person can come join you, make new friends, have even more nerdery, it's great. So please follow the Pac-Man Rule and make other folks feel welcome in your conversations. Okay, in terms of the beautiful setting we find ourselves in, we have multiple groves. There are 2 groves we get to enjoy. There is the upper grove, which is behind you, which is where we have food, we have drinks, we have lunch, we have snacks, we have a respite tent. There's sunscreen, which hopefully we won't need so much of today, but it's still up there, so be safe. We also have hand sanitizer, again, to be safe. We also have Tylenol, because all of this development stuff makes our brains hurt sometimes. And we have other resources you might need, like bug spray. I'll get to that later. We also have the lower grove, the picnic tables that are down to your right-hand side. That is where you're going to be able to lounge, eat your lunch, enjoy the sunshine, enjoy the great outdoors, enjoy each other's company. And so you have all of these groves to enjoy. But while you are enjoying the nature, there are some less enjoyable parts of nature we want to make sure we are aware of. First and foremost, there are wasps. Have folks seen them? I feel like they've heard all of my warnings and just gotten out of here. But in case a wasp comes up and tries to land on your table or generally pester you, please don't kill it. Apparently this releases secret warning signs to the other wasps that they need to come attack you even more aggressively. We don't want that, so please gently shoo it away, or maybe like throw some meat far in the corner that it can go after so it doesn't come after you. Wasps, who knew they work this way? The other insect we don't want to be bothered by are mosquitoes. At dusk, you will find there are many. There is some bug spray out in the sponsor area, and these, it is okay to kill. Just saying. The other thing that was pointed out yesterday is that there has been some poison oak spotted around the venue. If you're a city gal like me and you don't really know your way around plants, you can take my strategy of just avoiding all of them. But if you know what to look out for, keep an eye out. And if you aren't sure, remember the phrase, leaves of 3, let them be. So it has 3 little oaky looking leaves. You don't want to touch those. Okay, those are all of the warnings about the nature we find ourselves in. I am required to disclose to y'all. But let us move on to more fun things like prizes. Yay! So we've already given out a couple of prizes. Where are my winners at? I see them in the stage. Oh, Yeah, okay, we've already had a couple of contests won already, but you know we got more. It's Serverless in the Park today, so we got more prizes for you. We have a challenge today brought to you by Planet Scale. So we're gonna have another photo challenge. The way this works is you gotta head over to the Planet Scale booth, you gotta take a real cute photo with them, you gotta put it on Twitter, you gotta tag Reactathon and Planet Scale data, and then later today, before the last group of talks, we are going to announce the winner of the super secret special surprise prize. So that's how that's gonna work, so make sure that you spend some time hanging out with the lovely folks at Planet Scale to win prizes. Alrighty, that's been a lot of advertisements for things happening. How about we get into some talks happening, eh? Yeah, y'all ready? Are we caffeinated? Are we excited? Are we ready for less servers? Okay. All right, so we have amazing talks lined up for you today, just as amazing as we have in the last couple of days. So we have so many awesome speakers, I can't even say them all right now. But kicking off this morning for our lovely day of talks, which you can see the full schedule at serverlessinthepark.com. Kicking off today's talks is the GM of Serverless Cloud at Serverless Inc., publisher of the weekly Off by None serverless newsletter, and co-host of the Serverless Chats podcast. So if you want more serverless, this is the guy to talk to. So he is going to be opening today's conference with a keynote on the state of serverless. Please join me in giving a big, warm Serverless in the Park welcome to Jeremy Daly. Woo-hoo!
Awesome. All right. Okay. Super excited to be here. Beautiful place here, but I do have to start this talk with a little bit of bad news. So for all of you that were wondering, unfortunately, the slide advances. There we go. There are still servers in serverless in 2022. I know we're working on it, right? Maybe next year we'll see how that goes. But actually today what I want to talk about, we're going to start and sort of go through how serverless has evolved over the last 7 years. We're going to look at how the workflows and the responsibilities of developers have changed. We'll take a quick look at the tools, services, and the patterns that we've created over the last 7 years and what we've got with those now. And then we're going to talk about the groundwork that is being laid for the future of modern applications. And we have a great panel after this with Matt and Brian and Rob. And we're all going to talk about sort of what is next, what's after Jamstack, what's after serverless, and so forth. So that should be pretty interesting. So my name is Jeremy Daly. I am currently the GM at Serverless Cloud, or of Serverless Cloud at Serverless Inc., the creators of the Serverless Framework. I have been consulting with companies for quite some time, actually started a long time ago, so I do have gray in my beard, and I finally stopped dyeing it, so that picture's a little out of date. I started working with AWS in 2009, back when it was like EC2 instances. That was fun. And then Lambda in 2015. I blog. I have a blog at jeremydaly.com. I have a number of open source projects. I obviously just speaking. I publish that newsletter every week, and I am the founder and co-host of the Serverless Chats podcast. And I have been doing a lot of things, including trying to create this DynamoDB modeling course, which is taking longer than I have wanted it to. But if you're interested in modeling NoSQL databases with DynamoDB, go sign up for the newsletter there. And I'm also an AWS Serverless Hero, which is a great program that AWS offers that just kind of gives us some insights so we can go in and actually see what they're building and give them some feedback on that stuff. So anyways, I usually start every presentation with a quote from Werner Vogels that says, piece of AWS that is not serverless. Now the funny thing is that Werner's definition of serverless might be a little different than mine. It might be a little different than yours, and it probably is pretty much different for everybody. So we're going to talk about that a little bit as well. But I want to go back early before the serverless era. So let's call this the pre-serverless era. So these are the days, the beginnings of AWS, 2006 to 2014. So S3 launched in 2006, in March of 2006. Shortly thereafter, SQS went GA. And then it took 3 years. I don't know what they were doing for those 3 years, but to launch CloudWatch. We got SNS the year later. We got CloudFront that year, along with Route 53, which it does, global DNS. We got CloudFormation in February of 2011. And if anybody is wondering what you did before there was CloudFormation, we were using the console and writing bash scripts like a bunch of chumps. That's what we were doing. So DynamoDB came around in January of 2012. And then we got Kinesis a year later in 2013. And the reason why I wanted to mention all of these services is if you look at this list of services, these are sort of some of the core serverless services that AWS has, but this is all before serverless even existed. So all of this foundation, all this groundwork, or all this, this foundation was laid well before we got to Lambda functions in November of 2014. So once we got past that, we kind of got into the next 2 years, and I call these the wonder years, because we were really wondering, what is this new paradigm? What can we do with it? So in 2015, right after Lambda went GA, API Gateway was launched. Now, Lambda actually launched originally without the ability to invoke it via HTTP in any way. So you basically could connect to a S3 bucket event. There was Kinesis connections. There were a couple other things. But if you wanted to invoke it with HTTP, you actually had to call it with the AWS SDK using what was called the Lambda API. And then because this new sort of paradigm existed where they added API Gateway, and now you could call a Lambda function, use it to back an API, the serverless framework, originally called JAWS, that actually came into being. The first version of that was published in October of 2015, and they actually invented some pretty interesting things. It was presented at reInvent in 2015, had quite a bit of fanfare. So anyways, interesting, just interesting bit of history there. But anyways, Jamstack, which was coined by Matt Biilmann, who will be on stage next, this sort of came around. And this is the point in sort of the cloud where APIs, the API economy, you hear that term a lot, that was kind of coming about. And while all these people were building applications with, and APIs with serverless, there was no way to connect to a database, right? Other than DynamoDB or something that used HTTP connections. So for a year, or more than a year, people were building applications and they weren't even able to connect to RDS or some sort of cluster. Now, once they added this, it was pretty bad. It was slow. It was, there was all kinds of connection problems, but we don't have time to get into that. About the same time, Azure Functions hit the market. Athena came in November 2016. The interesting thing about Athena is this is one of those underrated services, but essentially this is probably one of the most powerful serverless services that AWS has, because this can look through all of your S3 data and actually query it just like a SQL server. Is pretty impressive thing. AWS SAM came out in November 2016, trying to build up, as a way that wasn't using the serverless framework to do this. And step functions were launched in 2016 as well, giving some orchestration capabilities. And then what AWS was doing at the time, and I am doing this very much so in the context of AWS. I think AWS led the market here. They're the ones who really sort of guided what we consider to be these modern serverless anyways. But they created this thing called the Serverless Application Lens, which was a way that, which tied to the well-architected framework, which essentially was trying to explain, okay, over the last 2 years, here's how people have been building serverless applications. This is what we think they look like. So that was their first sort of foray into trying to codify and give you some ideas of how to build serverless applications. Now, we get to the end of 2016, there's a whole bunch of things that have been added, but there's a lot of use cases. So you've heard all the complaints like, I can't do GraphQL, or I can't do this, or whatever. So in 2017, there were a whole bunch of things that happened to really expand the use cases. Now, first of all, again, bit of history, this is when Google Cloud Functions came into play. Fauna DB, Rob Sutter will talk about that, but some people got their hands on the Calvin paper and thought it'd be a good idea to build a database that followed those rules. Architect Framework, which Brian LeRoux will also be on stage next, so that was something that he co-created and is currently maintaining as well. And Google Firestore, this is the only one I marked as beta simply because Google leaves things in beta for so long. I'm not even sure it's out of beta yet, but no, it is. I think it took 2 years to get out of beta, but Gmail might still be in beta, I'm not sure. And then AWS Amplify was created. So this was another attempt by AWS to try to find a way to explain and codify how people should be building serverless applications. Now, when this came out, This was the same time that Fargate came out, so serverless containers. So already we're starting to kind of mix what we mean by serverless. AppSync came out, so the ability to do GraphQL with a dedicated service. This service came out in 2017 as sort of a pairing with AWS Amplify. And then Aurora Serverless, the first sort of attempt to make relational databases accessible by serverless applications. This came out in 2017 as well. Again, it was very cool, all kinds of problems with any of these new technologies, but not that big of a deal. It's still cool technology. Now, serverless application repository, this is another step, and I put these ones in, the idea of the lens and Amplify and the application repository, because knowing how to build these applications, things are constantly changing. You're always adding new technologies, new capabilities. You've got all kinds of people that are complaining that you can't do this, you can't do that. I get cold starts, whatever. So these are ways that AWS was trying to help codify how you build serverless applications. So this came out now, serverless application repository. I'm not even sure it's still there. It didn't work very well. All right, so then you get to the end of 2017, you've expanded some use cases, and the biggest issue that we had, though, was that everything that you were building with serverless was essentially net new. Right? So you were building new GraphQL APIs, or you were building APIs, or even doing things with CloudFront and S3 and whatever. We're starting to build some really interesting things, building on the Jamstack and all that kind of stuff. But the problem was that if you had existing applications, which most people did, most people that were willing to try serverless were people who were already using the cloud, it was very hard for them to integrate their existing applications into serverless. So in June of 2018 is when we introduced SQS as a trigger. Now, I want to think about this. SQS is a massively scalable queue service, handles billions and billions of events probably every day. I'm not sure of that number. I don't check my math on that. But this is one of the first services they launched. And for 3 years, it didn't have the ability to actually pull from a Lambda function other than running it on a schedule, which was terribly inefficient. So this was interesting because a lot of companies were using SQS as an event bus, and so they were sending events to this and they couldn't integrate those with serverless systems. So when this came on, this was actually a pretty big step. Google Cloud Run came into the picture there, just as a side. A company called Nimbella, so Roderick Rabba, who was one of the original creators of OpenWhisk, and what eventually I believe came IBM Cloud Functions, or whatever they call them. He started this company. This was interesting. This was another sort of container-based, similar to Cloud Run type thing entering the picture there. Lambda expanded to 15-minute timeouts, right? So you had a lot more processing capability behind the scenes. They introduced WebSockets, they introduced Lambda layers, which gave people the ability to sort of share precompiled code, so you didn't have to install that in every Lambda function, and also the runtime API, because some people were like, hey, I really want to run PHP on Lambda. And surprisingly, there were people who did that, and you got breath out of that, actually. So, and then the application load balancer came in, and this is another thing. If you're thinking very small and you're thinking about serverless and net new serverless applications, it's easy. You just put an API gateway up, and you can route all your traffic to API gateway. But we had companies that I was consulting with, as well as others that we saw, that basically had these massive workloads that are using EC2, they're using all these other services, and the problem is they couldn't find a way to route traffic to their serverless applications or split that traffic. So it was either API gateway to an ALB to their old or to their old system, and then put the API gateway in front for the Lambda functions. That was terribly inefficient, a lot of latency. So when application load balancer support came on, actually created a way for larger companies that had existing workloads to start using a strangler fig pattern and start routing some of their traffic off to their serverless applications. So that was actually sort of a big step. So we get to the end of 2018, we've got all these integrations going on, but we're still missing a few major components for serverless to kind of complete the full serverless picture. And remember, right from the beginning, serverless was very much so event-driven. So in May of 2019, we got the data API, which gave you a way to connect to Aurora Serverless via HTTP, no more VPCs. VPCs eventually got better, but at that time they were pretty rough. And then sort of the Peace Day Resistance, I don't know if that's the right way to say it, but anyways, Amazon Eventbridge, which was a enterprise messaging bus that was essentially an evolution of CloudWatch events, this came out. Now this sort of changed the game in terms of how people were now routing information between different services. So this opened up a really good possibility, not only for existing applications, but also as a way for serverless applications to start building out better microservice architecture. AWS CDK, that was announced at the same time at the AWS New York Summit. And then we got Lambda Destinations. And actually go back to Lambda Destinations for a second. So this is one of the things where AWS, I don't think, likes to say they make mistakes. They're not infallible. And Lambda Destinations was one of the first things where it's almost like a correction. So there's a thing called dead letter queues in asynchronous functions, which basically if the function fails, it will send whatever the event was or whatever the failed event was, it'll send it to an SQS queue for you or SNS topic or whatever. So they added Lambda Destinations, which gave you more control of asynchronous functions. You actually got more information. So they had two conflicting ways to do things. They also invented or came out with HTTP APIs, which was a rewrite of API Gateway that was a lighter weight version of API, the REST version of the API, because again, it was less expensive, it was more performant, lower latency, and so forth. And then because the connection methodology from a Lambda function to a database was so hard and so complicated, there's an issue with connection pooling. You can't do connection pooling from a Lambda function. So you had to have all these open connections to a database, and whenever it scaled, your database would not scale with it. They came out with RDS proxy to sort of fix that issue. So they were trying to fix some of these things, get us to a point where things got a little bit cheaper, a little bit more managed. We finally get Eventbridge. So we get to the end of 2019, and the problem is now we have all these primitives, we have all these things that we have to do, and Xavier Lefebvre wrote this article about the typical serverless architecture. This was early 2020. And a lot of people were like, well, that looks way too complicated. And it is kind of complicated. If you follow the diagram, it's not too bad. But essentially, this is what we got to with serverless applications, that in order to build a full serverless application, there was a lot of wiring. There was a lot of configuration. There's a whole bunch of things happening there. And it became this sort of typical serverless developer experience where you start off with this hello world example, very easy to do. You use Architect, you use Serverless Framework, you use SAM, you use whatever, and you can create these very easily. But then when you start looking at real-world production serverless applications, they quickly grow into these massive diagrams, and people get very, very frustrated. So after that, people are still using it. People are building, people are learning. There's tons of blog posts going out there. This is the movement. It's happening. But again, as people started building these complex architectures and investing a ton of time in these architectures, what ended up happening is they started bumping up against constraints. And they finally figured out, like, well, yeah, if I can only do so much processing, or if this is the timeout here or whatever. So there were a bunch of constraints, and there was also the issue where you had existing developers now trying to port some workloads over to serverless. So in 2020, this is sort of where a lot of these constraints got removed. I mentioned CockroachDB came on the scene as well as another potential solution for a database, because that still wasn't solved. But we got state with Lambda EFS integration. We got Lambda extensions, which gave us more control over the lifecycle events. And that was big for observability companies being able to read things like when it timed out or being able to ship logs and some of that stuff. Lambda container image support came along, basically saying, well, everybody loves Kubernetes, right? So if people are building containers, let's go ahead and make it so we can move those containers over to a Lambda function. It's not quite 100% compatible, but it works. And what they did with it is they expanded it to 10 gigs for a deployment size, which is pretty big. We also got 10 gigs of memory for Lambda as well. So some of these larger processing needs, some of those constraints were lifted. And then we got a new version of Aurora Serverless that was supposed to solve all the problems of the old Aurora Serverless. I have a Twitter thread on this where I disagree with that, but hopefully it'll eventually get there. But regardless of sort of where all these things are, there's so many primitives out there now that if you're a serverless developer, you need to know these primitives, right? So let's look at the serverless framework just as an example, because I don't pick on the company I worked for. But essentially, if you want to create a function, that maps directly to a Lambda function. If you want to create events, you have to say, I want to pull off SQS, or I want to read off Kinesis. You need to know the primitives. You have to map them to those primitives. And then any other resources that the framework doesn't support, you just have to create and use raw CloudFormation. Now, Architect, which is the framework that Brian maintains, Brian LeRoux, I think they did a much better job from the abstraction level where they didn't necessarily tie it to a specific service or they didn't necessarily tie it to a specific vendor. But again, it's still very much so like you want HTTP, well, that's a Lambda function. Or you need queues, that's SQS, tables, DynamoDB, and so forth. Right? So it still ties you to the primitives, and there's still some configuration you have to do that are specific to the primitives that you're using. Now with AWS CDK, you're still defining all those resources explicitly, and you still need to know those configurations. Now, there's something called constructs, if anybody's familiar with the CDK, that does allow you to do this cool thing where you can actually create, I think they're level 3 constructs, whatever they are, but you can sort of codify those use cases and take a lot of that configuration and wrap it up into the use cases, and actually Pulumi has a very similar thing called component resources where you can do that as well. So even so, you're still at some point in that code, even if you're using those constructs, you still have to know what they're doing underneath, and more importantly, you're still responsible for whatever gets deployed. So even if you have these nice use cases packaged up for you, in all of these situations, these are actually deploying infrastructure that you're responsible for as a developer. And this is one of those things where it's like, you have all of these resources, you have all of these primitives, you have all of these tools to build things, and really you can build pretty much anything you want to. The problem is that it's very likely that you're going to build it wrong. And so serverless developers now have new responsibilities. So it's not just about writing business logic. And again, this has changed quite a bit, right? So I don't want to say, like, if you're building EC2 or building containers that you're only focused on business logic. This is probably true for more of the more modern applications, but you're also responsible for sort of that cloud architecture and knowing what resources you need, knowing the limits of those, making sure those are properly configured. You have to do build and deployment pipelines. So your code is very tightly coupled to your framework that's actually deploying and configuring architecture. So that's part of you now. It's no longer like I write some code, I check it in, and then somebody else is completely responsible for how that gets deployed and what resources that uses. Monitoring observability, this has been a huge topic. There's a couple vendors out there that do this. This is something where, as a developer now, with distributed systems, you have to test in production. There's no other way to test, right? So you have to be able to see what's happening, because a few users hitting up against a dev environment is not going to show you where the holes are in a distributed application. So you need to have monitoring and observability built in to your code. You have to have it built in. You have to be able to monitor that and see what happens. And then if something breaks, you're the one who's responsible for it, because an ops person isn't going to know the details of what you're running. And then the other thing is security and compliance. We no longer have tools that are above, that are now network rules that can block things at the firewall level. Very much so, a lot of that AppSec is going to fall on you as a developer. And this sort of brings us to this new paradigm that we've seen slowly, where the idea is the cloud is better than you at a lot of things, right? And so rather than you writing all this code like you normally would in a single server in a monolithic type application, if you're doing things like error handling or retrying failures, the cloud does that for you now. Or if you're managing failover and redundancy, you don't have to write that in your scripts. If you're transporting data, or in some cases actually transforming data, there's all these services that do this for you, and they're much more efficient and much more stable with all the retries and all that kind of stuff that are actually part of the cloud services that actually do this. And then if you're orchestrating workflows, we used to write a lot of orchestration in just code, and we would say, do this, call this, if this comes back, then fail, whatever. The problem with doing that in the cloud, especially with something like a Lambda function, is that there's too many opportunities for that to break, for that to fail, and for you not to know where that station, even if it's IAC, even if it's infrastructure as code, CloudFormation, or Architect, or Serverless Framework, or SAM, or any of these things, that code is still a liability, right? And the thing that bothers me a little bit about configuration over code is the fact that that code can quickly become technical debt, especially when they add new features, they add new services. Your code, your infrastructure's code doesn't necessarily adapt to those new services that are there. So in terms of sort of understanding these patterns and how, which configurations we need and what are the right way to do things, this is something I posted in 2018 originally, end of 2018. There's a whole bunch of patterns there. I didn't make most of these up. These were just things that I saw, things that I was using, but I kept on asking myself, I'm like, am I doing this right? Is this the right way to do this particular thing? And surprisingly, this got a lot of good feedback. People were like, oh, that's how I was doing it, but I wasn't sure, and so it just started a lot of conversations. So this, I think, was really great. We got a lot of good feedback just in terms of how things are supposed to be built. And then this followed on where this idea of creating patterns and trying to figure out the right way to do things This sort of caught on, and Matt Coulter from Liberty IT, or Liberty Mutual, I get the two confused. Anyways, he created this thing called cdkpatterns.com. He was working with Dave Anderson and Mark McCann, trying to get Liberty Mutual to adopt serverless. And so the problem was that it was so new, still, even in 2020, that people weren't really sure what are the right patterns. Like, is this going to work? Are other people doing this? So by creating this CDK pattern site, he actually did a really good job of bringing the community in and getting buy-in on what types of patterns people actually wanted to use. And then about a year later, maybe a year later, the developer advocate team at AWS, Serverless, they created this serverlessland.com pattern site. This is a great resource, by the way. This has 100 patterns and with a whole bunch of templates and whatever. And this really goes into detail showing you how to configure certain things, and at least gives you a template and a starting point to do some of these things. But here's the problem. Even though there are starting points, you can still go in and change stuff. So, how do companies go now? How do companies now actually make sure that they can not only create what the standard or the pattern is going to be, but also enforce it within their organizations? Now, Kristi Perreault's going to speak a little bit later about Liberty Mutual, but I do want to mention this, trying to take too much of thunder away, but essentially, they've created things called serverless enablement teams, where essentially they codify those patterns, the CDK patterns, to try to enable day 2 pattern usage from new team members, meaning that all of that complex learning, all of the compliance, all of the stuff that you really need to know, the nuances of how a particular pattern works, it's already codified in the CDK. And they can just go ahead and use those patterns and deploy them on day 2 so that they can get productive right away. And Lego has something called the Platform Squad, and what they do is, this is to basically introduce and maintain those standards around everything from compliance to shared code, how observability, make sure things are checked off, the observability is there, and so forth. Really interesting, and it would be great if everybody had teams that could do this for them. Unfortunately, most companies don't, especially startups, small businesses, even companies that are just getting into serverless. So even if you have people that know this stuff, again, it takes time to develop this out. So 2021 was an interesting year because we saw a lot of companies trying to address the problem of complexity and say, these patterns are too complex, but we already know what they are. Most of us have used these patterns that have been in this, been doing this for a while. We know what these are. Let's figure out a way to combine the patterns. Or combine those primitives into patterns and create abstractions around those. So App Runner came out, which was a way to sort of just deploy containers more efficiently. Step Functions came out with their integrations to the AWS SDK. Amplify Studio came out, which was more a visual editor to create apps. And then a bunch of little things happened. Partial batch responses, event filtering. They launched a whole bunch of new serverless services like serverless inference and Kafka serverless. And then we got Lambda function URLs, and we got 10 gigs of ephemeral storage. These were all great things. These happened early this year, but they were supposed to happen last year. But while that was happening, Serverless Stack launches their new version that supports CDK constructs in there. IBM Cloud Code Engine comes out. PlanetScale launches in beta, I think in May or something like that, to address the ongoing serverless data issue. Akka Serverless launches as a new platform. Serverless Cloud, which is the product that I'm working on, was launched. And then I'm going to say this wrong. Xata? I don't know. I'm going to try that. I've been trying to figure it out in the green room. But anyway, Xata gets launched. I think they launched their beta September or something like that, as a new go-to serverless database. So there are a lot of people getting into the space to make it easier and a little bit simpler for people to do these things. And then meanwhile, Nimbella was bought by DigitalOcean, assuming DigitalOcean wants to get into the serverless space as well. So that brings us to sort of now, which I like to consider as the post-serverless era. Serverless is whatever you want it to be. It's more of a mindset than it is any set of technologies, but I look at it now in terms of where we want to go. We have everything we need to build modern applications, and that's really what this next era is going to be about. It's going to be about building modern applications in the cloud. And modern applications in the cloud may contain containers. They may have serverless things. They may be using other services and managed services and so forth, but essentially modern applications is where we are. So I just want to go through quickly a couple of these sort of where we've landed with a few different things. Pre-configured infrastructure platforms, so App Runner, Nimbella, as I mentioned, and IBM Cloud Code Engine. These are all things where you kind of just throw some workloads at them and they kind of figure out how to scale based off of that. They're a little bit restrictive. Edge computing platforms, so like Cloudflare Workers or Fastly, these are things doing edge compute. Great for low latency stuff, globally distributed. Some have KV stuff, limited execution times though, so they're better for lightweight workloads. So we're still not necessarily running our full applications on these, but great for things like edge compute. And then Jamstack is now moving to meet serverless, but also moving to the edge, right? So you've got SSR, SSG, ISR, whatever other acronyms you can think of. These are all happening now as part of serverless functions, as part of edge functions. They do things like framework detection, deployment management for you. You get both the serverless and edge functions there. And then this idea of integrated backends and extensibility, Netlify is doing some really cool things with Netlify Graph. They also have edge functions running on Deno now. So some really cool stuff happening in this space. If anybody was here yesterday, you may have saw Sean Wang mention this idea of self-provisioning runtimes. So this idea that a paradigm where everything that your program needs, all the infrastructure you need for your program, can actually be a paradigm program can actually be self-provisioning runtime. I think he realized how, including serverless cloud, and essentially what resources maybe for your focus on use cases, familiar patterns, workflows to do your piece of this. Behind the scene doesn't matter. One might be running in a far. It is. The point is that it needs. So these are all faithful apps. But if you like that, have is still very viable ways to do that. That is being his team is working the work deploying static things. This stuff with API gateway, how much it's evolved tremendously over the last 7 years. It's only been 7 years, so I'd say it's not your grandmother's serverless, but she wasn't using it. So it's evolved a lot in the last 7 years. So if you looked at it 3 years ago and you look at it now, it's completely different. So much has changed. The vast majority of the objections, a lot of people make a ton of objections like, oh, cold starts and this, and I can't do that, whatever. So a lot of those have been addressed, something also to look at. If you need to do anything, whether it's ML or it's database or whatever, there's most likely some sort of primitive or managed service for you that you can use. Configuration over code, again, not this trend that I like, but this is where it's gone to, where, again, let the cloud do more of the heavy lifting for you. Event-driven applications, they're back, right? So if anybody was doing programming in the 70s with mainframes, you probably did event-driven applications. Well, they're back, and that's what we're using now. And then growing complexity is still a major concern, for me at least, because it keeps getting complicated, and I think we have to move in this direction of simplifying it and building better abstractions as opposed to having to worry about all those primitives. So overall, I would say that the state of serverless is strong, but there's always more to be done. So anyways, that is my talk. Check out my blog, podcast, newsletter, course, and sign up for Serverless Cloud, and let me know what you think about that. Thank you.
Yeah, keep it going, folks. Keep it going for Demi. Woo-hoo-hoo. Yes, thank you so much.
You're welcome. Thank you.
Alrighty, so we are doing some fancy setups here because we got some special treats in store. You know we like to spice it up and not just have all of the same type of content. Yesterday, who caught the podcast episode with Syntax with Wes and Scott? How fun was that, right? So fun, amazing. And who all hung out at the after party? Amazing music, amazing bartenders, all kinds of fun stuff. So maybe some of the folks who hung out aren't here this morning. I don't know. We'll see. But again, please thank our sponsors, Code C, for last night's awesome after party. And we also want to give another shout out. We're going to have lunch coming up in a little while. And that is catered by our amazing caterers who are going to be just making our taste buds delighted. So please give them some love when you're grabbing lunch. Lifted Plate, also available for catering in the Bay Area. Alrighty, but without further ado, now that our set has been miraculously apparated here, we are going to have a panel coming up for you. Who's ready to get into the future of Jamstack and serverless, huh? Woo, woo, woo. Come on, y'all. Woo, yes. All right. So please join me in welcoming the moderator of the very exciting panel we have coming up for you here. Head of DA at Fauna, previously DA at AWS on serverless, and previous SaaS co-founder. Please give it up for Rob Sutter! Woo!
Thank you, Anjana. Thank you, everybody, for joining us today. This is the panel entitled The Future of Jamstack and Serverless. We have 3 distinguished panelists who will be joining us, and I hope that you'll take away some lessons about how we got where we are today with both Jamstack and serverless, how they're starting to align and how they're starting to diverge, and how we can project some of those trends a little bit out to expect what we'll be building soon in the future, what the future of these 2 technologies holds. So without any further ado, I'd like to introduce our first panelist. He's the co-founder and CEO of Netlify. He coined the term Jamstack in 2015, and he's since driven the successful adoption of the Jamstack across enterprises, startups, indie developers, web agencies, and more. Please join me in welcoming to the stage Matt Biilmann. Our second panelist, I think you'll all be familiar with. He's the general manager of Serverless Cloud at Serverless Inc. He hosts the Serverless Chats podcast, and he creates and publishes the weekly Off by None Serverless newsletter. Please welcome back to the stage, Jeremy Daly. And our final panelist is the CTO of Begin, the platform that makes serverless absurdly easy. He's also one of the maintainers of Architect, the framework for building functional web applications on AWS. He's been well known in the serverless community ever since the introduction of AWS Lambda in 2015. Please join me in welcoming to the stage Brian LeRoux. Thanks for joining us.
Not again.
All right. I told Brian when he arrived this morning there's easier ways of getting out of talking to me, but he was committed to the bit. So, the future of Jamstack and serverless. And I want to start with where these two technologies intersect and where they're starting to diverge. Or, as we discussed a little bit before, Jamstack versus backend serverless. Because that's where we started. Originally, Jamstack was oriented around how do I get this HTML out to the client as quickly as possible. And serverless was over here saying, how do I do things hidden in the back room on line of business applications? And of course, it's a gross oversimplification, but it's a starting point. It's not exactly the same anymore. Is this distinction meaningful, or are we starting to see a collapse of the two? And I'll ask you, Matt.
I think this distinction is still very meaningful. I think serverless covers a very broad range of what people are building, right? Like from serverless event processing for analytics systems and background tasks and all of these kind of things, where Jamstack from the beginning was really oriented around a shift in the architecture for how we built for the web. And that was sort of our core insight and idea behind starting Netlify, that we saw that you would start fundamentally decoupling the web UI layer from the whole backend business logic layer, where before this, like the normal approach to building any kind of web property was like having a big monolithic full stack app that coupled business logic, templates, plugins, data access all together in systems like WordPress, Drupal, or experience managers like Sitecore, AEM, Episerver, or in like application frameworks like Ruby on Rails or Spring or so on, right? Like where you really started building this idea of like a monolithic thing that did everything. And we saw this shift away from that approach to treating the web UI layer as a standalone thing that you can work on in isolation, deploy in isolation, get as close to your users as possible, and that has its own workflow surrounding it. And what we saw the possibility to do when we realized that that change was going to happen was to really build an end-to-end cloud platform around that web UI layer that incorporated both the runtime layer, the hosting and so on, but more importantly, the whole workflow layer for how do you release, how do you operate, how do you deploy, how do you collaborate on building web properties with modern web technologies. And I think where the ideas intersected, like obviously we were the first in the space back in 2017 that incorporated AWS Lambda into this kind of cloud platform. And that's now become sort of the standard, right? Like you have edge hosting, you have serverless functions. We're starting to see edge functions emerge as a standard layer of it, right? And we did that because we saw that often the web teams working on this web UI layer, they didn't just need to build just HTML and CSS and JavaScript and deploy that, right? Like they also needed a sort of a backend for the front end, right? Like this whole layer that you talk to all the different APIs and services through. You needed functionalities like scheduling, background tasks, and so on. That's still inherently tied to the team that builds the web UI. It's not a part of any of the API teams and so on. But that until this point required like spinning up a server somewhere and suddenly becoming a system administrator and running it, right? Like, and our philosophy about like that whole web UI layer was that we should strive towards a point where the web teams could just work in GitHub, write code, and the rest would flow from there, right? Like, so we saw a great opportunity of incorporating like serverless functions and latest like Dino edge runtimes into this flow, and keep that promise of just letting you write code, and then the rest happens there. And I think where there's a really interesting convergence now is, I think we're seeing in the serverless space that's like sort of outside of just the web UI layer, but the whole like how do we build the APIs that people are talking to, how do we build the infrastructure services that does more complex background processing and tasks and so on. Same ideas emerge of like, how can we get to a point where the teams working on that can just write the code and the rest flows from there. And that's been exciting to see, like from serverless cloud, like moving into that direction. It's a direction I believe a lot in.
And I think that's what I would take your question there. How do we build those aspects of managing the data and the workflows? And I think that's a natural segue into this question for you, Jeremy, with something like serverless cloud. You and I have talked about the front end generates a lot of data, and it eventually, when you become successful, only as a front-end developer with a web app, you now have all this data and you have a new need for a back-end application. So what does the growth path look like out of what's currently offered when you have to start building with line of business applications that you never expected to handle?
Well, I think that's the other thing. Matt makes a good point. I mean, there is a separation to some degree of building a front end, product website with some dynamic components that still has some functionality that needs to be written and needs to generate dynamic things, and adding edge functions and doing all that kind of stuff and integrating with serverless so that you can do some of that processing. I mean, again, what you're doing with Netlify Graph, like that's really cool because you're you're taking away a little bit of that heavy lifting of having to do authentication and kind of building that in. Makes things, oh, that's perfect. Makes things a little bit easier. But I think certainly what I've seen is I don't think I've built a website that just does, calls a couple of APIs or whatever. I don't think I've built that in the last 6 years, right? I mean, essentially every application we're building seems to have some sort of line of business that it is actually powering. So, and every type of application you're building on the back end most likely has a front end, even if it's internal, right? So in some of those cases, you don't necessarily need the edge and all these other things, but in some cases, you're building very complex administrators or, whether it be social media or anything that's very heavily data-driven, in some of these cases, just a static site, even static sites that are, incrementally regenerated or have some rehydration, aren't necessarily cutting it for some of these larger applications. And so what we try to do at Serverless Cloud is say, that natural front end, that ability to build things quickly, to distribute things around the world, that is a very solved problem. I mean, I don't want to say 100% solved, but Matt and his team and Guillermo and Vercel, like what they've done is they've revolutionized that sort of process. And I think that has gotten us to a point now where it's like, hey, we can almost, I don't want to say commoditize that because that's not the right way to say it, but essentially that piece is like a foregone conclusion. So now how do we get people to the next thing? How do we get them to say, okay, now we're collecting all this data from the front end, or we want them to be able to, run all these complex applications behind the scenes. We want to be able to, have WebSockets open because we want to wait for a particular thing to respond, and we don't want to do that synchronously. Or, what are all of those different complex applications that people are building and thinking up now? What are those things? What are the interfaces into those things? And how do we make that so that you don't have to have one team that's building on this platform and another team that's figuring out CDK and these other things on this platform, and then saying like, oh, and then we're going to use this other database here. We're going to use Fauna, or we're going to use PlanetScale, or we're going to use this. And now you're managing all these different services with multiple teams that aren't necessarily communicating with one another. So I wonder, with the split of front end and back end sort of as two types of developers, I feel like that's merging now and everything is becoming full stack. So I think Jamstack is naturally evolving to full stack. I think you'll still have some people who will be focused, and again, I could give it up to people who build on Next.js or any of these front end frameworks because it's more complicated than what I do on the back end, I can tell you that. But like, I think those skills transfer just fine. And as long as you give someone a platform that allows them to do that, those applications can be built full stack all the way through. You just have to take out what Netlify and Vercel did with reducing the complexity of deploying those sites, globally at the edge and the CDN. We have to do the same thing to deploy the back-end line of business applications.
Right. Well, and from that perspective, the segue for me then, you talked about these disappearing frameworks is what I call them. It's convention over configuration, where when you deploy something to your provider, whatever's in the Pages API directory in Next.js, for example, gets deployed as functions. Where? I don't care. It doesn't matter to me. You just do it. But also at a certain point, I might start caring.
Right.
I might have other reasons why I want that on provider A instead of provider B, or I want it at the edge instead of on general regional compute. Brian, what do you think about the idea of these disappearing frameworks? And is that something that we could see on the back end as well, this convention over configuration option to speed up this process?
I hope all these frameworks start disappearing. That'd be great.
I thought you might say
that. Yeah. In seriousness, I think Jeremy touched on it really beautifully. This is a moment for the web developer. And the front-end web developer didn't even used to really be a job. That was like a fairly recent thing, actually. If you were a web developer, that meant you did the whole thing. And then frameworks got involved. And the frameworks at that time were things like Spring and worse. And you weren't even writing HTML, you were writing Java, and there was kind of HTML in there, and the JavaScript was sort of this separate thing, and these worlds diverged. And what we're seeing happen right now is the web developer, the front-end web developer, is becoming empowered to take that back and write that code themselves and deploy it themselves and run it themselves and architect those systems themselves. We don't need to load balance monoliths anymore to get a dynamic application running, and that's a wonderful thing.
Yeah. Is there, and this is for anyone that wants to answer it, is there an aspect of the disappearing framework for the back end, or meeting developers where they are, maybe is another thing, where in the case of Next, it brought into React the functions. So think about something like Spring. We all like to dig at Spring or Rails or whatever, but the fact is there's a tremendous amount of websites out there that are built around that. Why haven't we seen the, okay, thank you for your Rails app, here it is deployed as a collection of SQS for Sidekick queues.
But take Twilio, right? Like more than 3,000 developers, like a 60 billion market cap company or something like that, right? Like if you go to Twilio's logged in experience, all of that runs on Netlify from the web UI perspective, using like a federated approach to have like hundreds of different teams working across different areas of the console, with different front-end frameworks, technologies, and so on, right? And obviously, the back-end services that they consume, Twilio's messaging API, their call center APIs, and so on, have whole teams around them that specialize in them, that build them, that work on them, and so on, right? And I don't see any interest from Twilio in saying, hey, we want all of these 3,000 developers to work on like one full-stack application. On the contrary, it's like a feature, not a bug, that you can actually like say, here's the web UI team. They have like their straight path to iterating really fast, to deploy like hundreds and hundreds of times a day, to move at a different speed that any of their backend services can move on. And each of those service teams can work in isolation. And we are seeing that even from an ecosystem perspective, where you sort of outsource a lot of those backend service teams, right? Like where you say, okay, we need authentication. Let's pull in Auth0 as a service, and we've basically outsourced that whole service team to an external company. We need content management.
Serverless, by the way. Outsourcing.
Absolutely, right? But
Yes.
I think that's where I'm thinking on like different than just putting everything in one big CDK file, like, and with one framework driving everything. I think we actually see this decoupling move to a world where everything is composable, and where I think we'll see real serverless frameworks emerge and tool stacks emerge is around like, how does the teams that are building those APIs and services to be composable and to be part of this landscape, how do they execute faster? How do they build faster? And how do the developers that needs to glue them together, typically with like background tasks, with like pops up services, with all of that, how do we make life as easy for them as for the teams iterating on the UI experience, right? Like, and I think there we'll see a lot of innovation in the next couple of years.
Yeah, I mean, and I mean, again, I think your premise there is right, but I also think it's very much so about choice. So, I mean, one of the things we do with Serverless Cloud is you can build a front-end component and build that in one app, and then you can build your back-end component in another app. So you can have multiple teams managing separate things. But for the team that's building a back-end app that wants to have a quick admin and wants to be able to deploy some HTML to support that, you know, whether it's a SPA or it's something more complex with Next or whatever, you know, they have the choice to do that, right? And so that to me is where what worries me about abstractions, and this worries me about Serverless Cloud, it worries me about architects, it worries me about any abstraction. Serverless Cloud, it worries me about what happens when you hit that limit. Configuration, you can't make Netlify to power. And it's a good part of the process. Integrated as an admin. Again, I do think that. And then the only other thing I'd say too, but hard to get away from. Build a lot of that stuff with serverless. Very much so like to see. So I do think that you've got millions of developers who would want to build a full stack application that it could be as simple as a website front end that connects to your HubSpot API, right? And then you can do that in a million different ways, but it may be more complex. So I think the idea is to try to find a way, and again, not any specific framework either. I'm not talking about a framework. I'm talking more about just a convention that we can come up with that will allow us to do this, which is why we talk about infrastructure from code. But essentially giving you that full framework, or I don't want to use that word, that full process to allow you to deploy those things and replace your WordPress sites. That's where I want to get.
So I want to dig into a thing here, and I think it's important to be specific about terminology, because I think words are important, and I think it's important to be very specific about what we mean by serverless when we talk about serverless. So WordPress is kind of serverless if you use their hosted thing. If you run it yourself, you're no longer really serverless, and that's okay. So serverless, to me anyhow, isn't a particular technology. It's an ethos about outsourcing. It's an idea that there's going to be someone out there that does this, thing that I don't do. Like, I don't rack servers anymore. I used to do that. Yeah. And now I rent them by the millisecond from Amazon because they do that. And they're going to have way better people doing that than I'll ever be. And so in a sense, like, things like WordPress are okay. Like, if you're building a blog right now, it might be worth examining that as a good use of your time. WordPress has been doing that for a while. Maybe just let them do that, and you can focus on your business problem. Now, it's cool to build a blog. I'm not saying you're bad if you built a blog. Go for it. It only takes 3 minutes. It's fine to do that. But to build WordPress doesn't take 3 minutes. It takes a lot of time. And so in a lot of situations, it is serverless to do that. This word serverless has grown ambiguous and kind of problematic, and so it's hard for us to be specific when people say, oh, serverless is functions, or serverless is this particular framework or product, because it really isn't. Serverless is about focusing on your code and your business logic, which is hopefully unique, because if you're not writing unique code, you're not creating something that's uniquely valuable, which is a really bad use of your time, and you don't have a lot of time in this life, so you might as well spend it on doing something valuable and outsourcing that stuff.
Well, I had saved this topic for later for us
sorry.
because I know this goes on, but no, now we're going to dive right into it. Whenever serverless people gather,
they argue about
two things inevitably come up. Yeah. One is serverless has servers, and yes, we all know. The second is, do we need new words?
Yes.
Around this?
Yes. So this has been my thing that I've been dragging around lately. I've been calling them functional web apps. So serverless doesn't mean anything. It's too ambiguous. It's about an ethos, but it gets applied to marketing. Functional web apps is a term that we're coining, or saying FWAs, so that we can be specific about what we're talking about. And what we're talking about is building with Cloud Functions as your primary abstraction, deploying with a managed database, and using infrastructure as code. And these are all just really good practices to have anyways, and it's a 3-letter acronym so you can remember it. So when when I'm talking about functional web apps, I'm not talking about Kubernetes.
Yeah. The great heisting of the term cloud native.
Yeah,
the Cloud Native Foundation was one of the great crimes against computing in the 2010s. I posit.
Yeah, so Cloud Native gets associated to Kubernetes, which is essentially running your own servers.
Yeah.
This is like the opposite of Cloud Native.
Right.
But for me, Jamstack is cloud native. Serverless applications are cloud native. You're taking advantage of the other providers there so that you can create value for your users by writing code specific to your business processes, or creating a front end that improves the developer experience for them. So I agree with you that words matter, and we may need a replacement. The first time I ever met you, I don't know if you remember this, was in August of 2019 at the Serverless Heroes event. I just started at AWS. And one of the topics on the internal panel was, do we need a new word?
Remember that?
I hope it's okay that I say that. Now you all know. But I remember, like, the very first day that I met you, it was, do we need a new word? And of course, some people like the word.
Yeah.
But this does come up a lot. I want to ask you the same question, but around Jamstack. Like, has the ecosystem evolved so much that JavaScript APIs managed services is no longer an accurate reflection of it?
I mean, a while ago, we changed the way we put Jamstack from being capital, from the abbreviation originally, to just being a word, because it felt like the core tenet of it was much more this idea of decoupling than the specifics. I still think there's there's a strong sense of the decoupling, meaning that you build a sort of stateless UI layer and consume a bunch of different APIs rather than building like a full stack, everything, templates, plugins, business logic, data access coupled together. I think where we've seen a lot of evolution and are seeing a lot of evolution right now is like, even in that stateless UI layer, where does stuff actually run, right? Like in the early days when we started Netlify, AWS Lambda wasn't really a thing, right? Like so, but also a bunch of code being possible to run in serverless functions, still typically just like stateless functions deployed with the rest of your UI, right? Then we started seeing new patterns emerge around that, like ISI and distributed persistent rendering and deferred static generation and so on, right? Like taking advantage of that layer. And now we are starting to see this new streaming rendering layer in edge functions become a part of the stack, right? And some people will argue that then we should call it something else than Jamstack. To me, it still feels like it's more about how you use it, right? Like, of course, if you start building a full stack application in edge functions and couple together like data access and business logic, templates, everything in sort of a full stack framework and work with it that way, that's obviously not a Jamstack approach, right? But I think most of the people, like if you look at something like Hydrogen from Shopify, right? Like it's very different than a Jamstack application looked like 5 years ago, because you have this complete streaming rendering layer, but it's still very much the same model, that you have this stateless UI layer that talks to Shopify's API and generates like React rendering streams for you in the end, right? It's just a question of you've shifted the runtime layer from the browser to this streaming layer close to the browser. But architecturally, to me, it doesn't feel like a fundamentally different approach. It feels like mentally you have a build step, you push that out to the edge, you have an API that you stream from and talk to, and not surprisingly, it runs really well on a platform like Netlify's, right? Like, so I think it's a good question of whether we need a new name. Like, I think the challenge with any of these architectural names is that, like, just like with serverless, from the day you coin them, people will start saying like we should coin another name, right? I'm probably at this point in the stage of like let's keep it as long as it makes sense, and I think it still totally makes sense.
I think there's a shared understanding still, even if we don't like the term, of what we mean when we say Jamstack, serverless, less so.
Yeah.
So I think there is that argument for changing.
Well, I think the term serverless too has just it's gotten to the point where everybody labels everything serverless. In 2018, 2019, I did a talk in at a serverless days conference, and my talk was stop calling everything serverless because essentially that's what people did. Everybody was like, well, this is serverless. I mean, that's the thing, like serverless containers. I asked Werner this on the podcast. I said, is there such a thing as serverless containers? And of course, he, I think, had to give the AWS line of, yes, of course there is. So I don't know if I got a straight answer there, but I mean, some of those things, for a long time, it was sort of bothering me, and that because I was like a serverless purist for a while, and then I'm just like, you know what, call it whatever you want. I know what I'm building, and actually, I would disagree with Brian just a tiny bit about outsourcing to something like WP Engine or whatever it is, because I do think the technology does matter. It is a little bit about the technology, not necessarily about the technology choice, but like just outsourcing something to WP Engine or WordPress or whatever, or even outsourcing to Elastic.co or something like that. It's not as elastic as it sounds, right? And so there's an elasticity there of, that's one of the tenets of serverless. So scale down to zero, we abandoned that a long time ago. Unfortunately, pay for value or pay for what you use, I think, is what we go with now. But utility, right. Yes. But the elasticity of it is still an important piece, and the technology has to do that. And this is one of the things where, if we go back to Jamstack and edge functions, the biggest problem I have with edge functions has nothing to do with the fact that they're super fast and they can stream, they can do all these amazing things. The data replication is the biggest problem. So your best case scenario using edge functions to do dynamic rendering is likely to route to the nearest region, right? So you still are looking at regional distributions. You still have to have some framework or some process for deploying and replicating your data. And then even if you're using like KV or some of these things, if you're doing more complex stuff, you may be routing to an edge function that gives you the ability to do authentication and maybe maybe like rewrites of the origin and things like that. Really great stuff that you can do. But when it comes to actually rendering some sort of dynamic data, you're still going to have to reach out to a data center somewhere. And
Global tables.
Global tables, right, solved.
Just everyone get on DynamoDB and we're good.
No, I think
Well,
that's actually like a really...
items that Jeremy just mentioned. And how do you get around this? Because there are levels of coming in, and there are different parts of that workload that will need the full round trip. And then there are different parts that can be pushed out to cache or cache-like things at the edge, like JV. I apologize.
That's part of, yeah, well, but I totally
Come to
agree,
my
right?
talk.
Again, but I think that's also part of why I think that when people really start using, like, it's still a very new thing, right? Like, it's only really now, like, I would say that it's only really since we launched Edge Functions that you actually have an intuitive way to work with an open standard runtime at the edge layer, right? Like, so we're still in the very early days of this, right? Like, and I think there's a lot of excitement around it. I think as people start building applications in that layer, I think they will actually end up with a very Jamstack-like approach where we've seen approaches like taking the core data that your application need in build time, you bundle a core piece of that with the edge function, and now you can get that whole streaming rendering really fast, and only the data that's not part of that core set you go to APIs for. I think we'll see, like, because I think people, it will also lead to a very different adoption path for tools like Fauna that until now had this promise of like, hey, we are actually building data tools that does true global distribution. But anytime people were like, okay, so let's build an app in top of them, they ended up deploying a serverless function to like a single region. And it was like, okay, how do we actually use it, right? Like, that's the next part. We'll enable the whole ecosystem to actually tap into tools like Fauna, like Convex, like PlanetScale, and build interesting things of them. But I still think, to your point, that like 2 years from now, we're not going to see every company in the world store their data all over the world, because it's just not feasible, right? Like, so it has to be around, like, how do we pre-build some of that data? How do we cache it? How do we build intelligent replication patterns that doesn't replicate everything? And I think a lot of that architecture that emerges around that will look a lot like
Sounds like
this
Netlify's
idea of
building
a
a database.
Jamstack. No, we are absolutely not. Again, because we're not building for these full stack apps. We're treating for, like, how do you build this web UI, and how do we make it really easy for you to connect to all the different APIs, databases, data sources that you need both at build time and at runtime, right? Like, but again, we don't believe in like a vertical stack for building this like monolithic application. Again, we believe in this decoupled approach.
I do want to mention one of the other missions besides getting rid of WordPress. If we could eliminate the pulsing gray placeholder boxes, if we could get rid of that, that'd be amazing. That, and then also scroll bar hijacking. If we could get rid of that, all right, and then the world would be a better place.
Yeah. No doubt.
Well, so I can't help you with any of that. But a lot of what we've been talking about really is oriented around developer experience right now. And we've slid in and out of it, and I've been wanting to come back to this topic. But even things like when you think about edge functions and the way that they deploy radically differently, I mean, most of them that I've seen, it's a second. You're looking at second deployment times, which is just not what you see from traditional cloud applications. That can change an entire model for the developer of, listen, I'm gonna push that data all the time on a separate branch, and I have a data branch, and it republishes all of my edge functions so that they have that data as their own cache as constants, right, in the V8 isolate. So that's a really interesting thing that to me is one of these future experiences that we don't really know what it's going to look like yet. So then the question is, what areas are we seeing in developer experience that are sorely uncovered today, and how do you think we're going to go about fixing them in the next 5 years?
I'll ask you to help fix some of them, right? Because like one thing is like that whole web UI layer, right? But then every time one of our teams need to start building a new API for that layer to tap into with all the performance characteristics, observability characteristics, scalability characteristics, release management characteristics that you want, that always turns out to be like a long process of them working together with an SRE team and putting it together and so on. And that's where I think that there's such a huge potential for this idea of infrastructure from code, where what if those teams could also just like start writing code for solving a problem, and the rest would flow from there.
Right, and I think that's you mentioned, of course, edge functions, and those deploy instantaneously. To set up a new AWS account, deploy a CloudFormation stack, to deploy a CloudFront or a CloudFront distribution.
CloudFront.
I mean,
Half hour.
might as well take half the day off, right?
Yeah.
I mean, so one of the things we did at Serverless Cloud was we said, well, we know this takes forever to do, so what if we just pre-provisioned a bunch of these services that we knew were most likely going to be part of every stack? So that's what we did. We built an AWS account vending system. So when you go and you spin up a new instance, it takes about 3 or 4 seconds, and we just basically update a line in DynamoDB. We're looking at Fauna. Anyway, so you upload DynamoDB, and then basically that says, okay, this account is now associated with this particular user. And so that gives you the capability to then deploy code very, very quickly. And even when you deploy a new instance in Serverless Cloud, it takes about 14, 15 seconds, and then a little bit more if you do a build step. But another thing we're doing too is we're actually running our build step in Lambda functions now with ephemeral storage. Yes. So we can do that. We can build, and again, Netlify has a great little game you can play while you're watching your thing deploy and build. We can do it in 30 seconds, right? So we can do that in 30 seconds, actually 30 seconds or less. So there's some really interesting things you can do to speed up the development, to speed up the deployment, and some of those things. But where I think the bigger topic is, and this is something we were trying to think of with infrastructure from code, is when you say you put a file in the pages directory, or you put a file in the functions directory or whatever, and then maybe you configure the TOML file or whatever to do certain things. But you're very specifically thinking about, okay, well, this is going to be a function, or this is, and I want this to go to the edge, or or if you're doing, Next.js and you're saying like, I know this is just a convention where it says, okay, when you deploy this function that needs to do X, Y, Z, we know that it needs to connect to a database, which means we know that we either have to find a way to optimally route that to a closer data center, or we have to know that there's certain data that can be pre-packaged. And even better, what if we could say, look, at this particular edge location, you're always loading this type of data. So why not automatically ship that data there for you automatically? Why can't we figure that out for you? Why does the developer have to do that? And the more you think about, and I mentioned this in my talk, but if I'm deploying an API endpoint, right? I have to specifically say right now that I want that to deploy into a Lambda function. But what if I do want it to deploy into a Fargate container? Or what if I'm using SQS now because that's the right method for me to be polling off of a particular queue? But what if that changes? What if I do need to add SNS in there or whatever? That changes with the use case, not necessarily with my code that I'm writing. So what if the code was, or what if the system was smart enough to figure out this code needs these resources to do that? And then you start looking at things like edge functions, you start looking at things like data replication and whatever. Like if you're getting no traffic in a particular region, well then don't ship data there, right? Don't deploy to that edge. Don't worry about, maybe you have longer caching times or whatever. Like that stuff should be figured out by the platform for you. And that's where I think the developer experience needs to go, is we need to get back to this idea of essentially building WordPress sites, but then just have them deploy to the modern infrastructure that we have around the world now, which is amazing, right? And that's where we want to get. But we got to take that developer experience back to a point where it's very easy for these people to develop, and then not necessarily worry about how do they run it at scale.
All right. So
you look like you want to say something.
I'm going to be the words guy again. So developer experience gets chucked around quite a bit. And sometimes people even pit it against user experience, which is a fallacy. Those things don't have to be against each other. You can have a great developer experience and a great user experience. It's totally possible. Most what people mean when they say developer experience, they're talking about familiarity. So sometimes people will encounter a new project and they'll be like, this is such a bad DX. But what they mean is, I didn't use TypeScript. Or it's not using the framework that you knew, it was the one I knew. And that's not actually developer experience. Developer experience is when you've got a bug, it's Saturday, you got paged, and you need to fix it. And now you're like on the clock, on a weekend, you got better things to do, and you've got to fix this thing. That's developer experience. What happens next? It's when you get a new requirement and you've got a deadline next week and you've got to do it this week. That's developer experience. Developer experience is what your day-to-day life is like using the tools that you've selected. And if those tools are a bummer, then you've got a bad developer experience. And if they're awesome, then you've got a good developer experience. And it tends to be when you get better with your tool, it becomes more familiar to you and it seems like less of a bummer to use, and so you'll anoint it as a good developer experience. Developer experience ultimately comes down to clarity about how you can go and fix something or build something. And Usually that is familiarity to me. It's also about tight feedback loops. It shouldn't take you 3 minutes to see a change on your website. It should take seconds, because we have the technology to do that right now. And if you have a bug, you should know the line number where that bug is. So you can go to that code, fix that code, deploy it in a few seconds, verify it that it's been fixed, promote it to production, and then go drink mimosas because it's fucking Saturday. And that's what you want to actually be doing. That's developer experience to me. How that manifests really depends on framework to framework, but for me it's about having great local dev and great visibility and observability into your system when it's running.
Didn't prepare this topic, but let's talk about observability, because I think this is one of the things that comes up, especially with serverless and Jamstack applications. You no longer have an agent in your container watching your memory and your CPU usage, right? You now have everything distributed everywhere. What have you learned, or what have you seen as the most appropriate ways to address that?
For me, it's about single responsibility functions. And I know that this is, everyone's going to have a way to deal with this, but if you split up your application, by the way, all your applications already are a bunch of functions. So when I say single responsibility functions, I mean functions that do one thing and do one thing well. And ideally, those functions are deployed separately in isolated containers. But maybe that's too big of a step, I don't know. But if they are deployed separately and they're named well, debugging becomes pretty easy. If I have an error on the get user contact form function, I know where my error is. I don't need distributed tracing. I can just go there and fix it. If you have a function that calls a function that fires an event that fans out on SNS and that calls thousands of another function, life gets tricky. And this is where you do need some form of tracing, and there's tools for this in AWS. It's getting kind of sophisticated at that point, but those are basically the last knife in your boot is this thing called X-ray, and then otherwise you're chasing logs. And actually yesterday, or maybe the day before, I heard someone say that serverless eliminates DevOps. I don't know if that person's done much serverless development. That's super not true. There's still lots of logs. There's still lots of grepping logs. There's still DNS. So,
Jeremy, have you created any music videos that have created any controversy around the concept of whether serverless reduces your operations?
Well, I mean, I believe the line was, "I'm going to reduce your ops, not I'm going to eliminate your ops." So,
but people heard what they wanted to hear there.
People did hear what they wanted to hear. Actually, Charity Majors. So I had a good chat with her. We had a good laugh about it, because then essentially she wrote an article about this. It was like, it should be, "I'm going to improve your ops" or something like that. And I said, well, I mean, you write a Hamilton, it was like 5.5 minutes. It took me a while to write that. So, I mean, I'm like, you're limited lyrically about what you could fit in there. But no, we talked about it quite a bit. And I think that the idea here is to say that, there is this contention, I think, where people like this hashtag #NoOps thing, where it's like, oh, I don't need an operations team. It's like, well, maybe you don't necessarily need an operations team, but you still need somebody who knows the cloud, knows the infrastructure, can, again, interact with either a monitoring tool or with AWS's built-in monitoring tools and so forth. But it does significantly reduce a lot of that overhead. I used to rack servers as well. I think I have scars on my hand. Every time I opened up a server, I would always cut myself. But I used to do that too, right? And we don't do that anymore. And I also don't have to worry about driving to the co-location facility at 2 o'clock in the morning to swap out a drive, right? Because the drive went down. Like, a lot of that stuff is just gone. But then you get rid of having to upgrade operating systems and having to, do patches and all these other things that you might have to do. Or again, my servers just update in the background. Like, I always have like the latest version of the server because they do it for me and I don't have to worry about it. So it significantly reduces a number of a lot of that, like, again, undifferentiated heavy lifting, everybody uses that term, but sort of the toil, right? The stuff that it just doesn't add value to your life. Whereas if you are on an ops team that is building modern applications using some sort of serverless technology or whatever you're doing, you should be spending your time optimizing the pipeline and the deployment workflows. You should be automating as much as you possibly can. I forget who I talked to, but basically have a rule that essentially anytime any type of request comes in to ops, that the first thing they do is try to automate it. So if it's a request that it isn't automated, they try to automate it. And that's a really good process to do. And if you have people that can be dedicated to doing that, you can also start writing more scripts and writing more, so it's just, your ops gets so much better because you can focus on the things that actually matter as opposed to, I mean, not that keeping your servers running doesn't matter, but somebody else is doing that for you, right? I mean, so that's a big part of it.
IAM security is also another big part of it.
You need to know that, right? And having security experts that understand how to write IAM, I mean, essentially you do need to get a PhD. I think they offer it at Berkeley, I'm not sure, but you have to get a PhD in IAM in order to understand how a lot of those different things work. I mean, I wrote a post not too long ago about IAM with DynamoDB, and I had Alex Debris, who is the DynamoDB guy, say like, I didn't even know you could do that. And I'm like, yeah, there's all these things that aren't well documented and they're just in there. But yeah, the only other thing I say about observability is, and I think, there are a lot of observability tools out there. Lumigo's a great tool. Datadog's a great tool. I mean, these do really nice things. Honeycomb's an amazing tool. I feel like distributed tracing is one of those things where I have used it so few times that I'm not even sure it's not. I mean, as long as I have some spans, as long as I know that it called something or whatever.
CloudWatch Insights is pretty good.
It's pretty good. Yeah, I mean, and not that these other tools do better other things for you. The interface is sometimes a little bit better, a little easier to use, like the fact that they span across multiple regions and applications where it's a little bit hard to do that with AWS. But yeah, I mean, I do think observability is a huge piece of it. And again, it is not no ops. It's just a matter of I guess #better ops.
Yeah, I like the concept of you're moving your ops from a cost center to a value center. Right.
Yeah.
Yeah, good way to put it.
Yeah, so there's like we ended up with like two topics, right? Like one around ops and where it's going, and the other around observability, which are fairly different, right? Like I think Seldo from our team, the NPM founder, he had a really good blog post with this like illustration of how complexity for developers day to day have moved up, and the complexity lower down has become really big companies, right? Like so one interesting piece, for example, back when we were all touching racks and servers and running to co-location centers, there were probably a lot less people doing that than there are today. Right? Like today there are way more data centers, way more servers, way more people doing that every single day, right? But we have companies that just do that basically, right? And we don't have to do it ourselves. And I think that's a continuous evolution that keeps like on the flip side, back when we were doing that, we didn't have to think about like responsive websites built for many different device types or mobile optimizations or performance over 3D connections and all of these different areas that now developers have to deal with, right? So we keep seeing the complexity shift upward in the stack, and we keep seeing companies taking care of the lower levels, right? Like it's not that it goes away, it's just like on the contrary, right? Like there are more and more people working in that, and I'm sure in the future there'll be a lot more people working in ops than right now just because software keeps growing, right? But we'll build layers of abstractions around it that allows us to, as developers day to day, focus on the value we are building for customers and not on the lower layers. And then when it comes to observability, like observability is an important thing of like that we often end up delegating to developers, that you might build a thing and you have it whole thing working and you can show it to your colleagues and everything, but before you can put it into production, you have to instrument it, you have to make it observable, and that ends up being a very long process often, right? Like it often takes longer to get that right than to actually build the thing, right? And that's why I think there's a lot of opportunity as we build more opinionated platforms. There's opportunities for us as Netlify to really say, like, if you build and deploy the web UI with with the architecture we propose, we can instrument it for you essentially, right. And we can make sure that the instrumentation is there, and then we can make it flow to the right places, right? Like, so we're now collaborating with Datadog, with New Relic, with Sumo Logic, with Logtail, and so on. And you can just enable one of them and we'll start shipping the data there. They've prepared ready-made dashboards to make sense of it and so on, right? Those kind of patterns, I think, makes a lot of sense. And when I think observability in general, I think about three things. Like, I think in the end, it's about, as developers, we want to know three things. The first is like, is our system working, right? Like, is it up or down? Is it performing with the right, like, performance? Are users seeing stuff fast enough? Are they able to do their things? And that's sort of one level of it. The other piece we want to know is like, when it's not working, how do I figure out where it's going wrong, right? Like we want to be able to debug, and we want to be able to understand specific pieces of like how, like what went wrong and how can I fix it. And the third piece of it is basically like what are the users of the system doing with the system, right? Like, so those are the layers we are thinking about, and I think we're doing more right now for is the system working in terms of just being able to have like an integration into any of the common DevOps platforms and just get ready-made dashboards immediately, be able to see that. We're doing quite a bit with things like if you open a deploy preview on Netlify, you will have like a panel on the side where you can directly see the serverless functions logs for the specific deploy preview you're watching, so you can easily click around, see what happens, get feedback, and so on, right? And I think we can still build a lot more tooling around that to make it easier to understand like what's wrong. And then I think there's another layer of more marketing tooling around like how do we figure out what our users are actually doing with our system.
Right.
Yeah, and I like that mental model too. And I mean, and one thing you mentioned too is this idea of auto instrumentation, and or just understanding how to instrument. And one of the things that a lot of these observability companies do is now with like Lambda extensions, for example, and they can just go ahead and just put something in there, inject it into your runtime, and then because you're using the AWS SDK, they can hijack that, and they can detect a lot of those things and do that tracing and some of those other things that are happening there. As soon as you start adding things like Fauna, or maybe you're calling external systems or other APIs, now you've got a little bit harder to instrument those things or whatever. That's one of the same sort of approach again that we took with Serverless Cloud, is to say like if you want to write an API, you do API.get, right? So whether it's Express or whatever, who cares, right? It just does what you needed to do, and then you make a call to data. It's data.get, data.set. If you want to have an event, it's event.on to read an event, or event.publish. And the thing is that those abstractions themselves, because again we're building this in a way that is sort of an ecosystem, all of those abstractions can then be instrumented automatically for you, right? So we can understand what happens at each one of those because you control the larger sort of SDK around it. So I think there's a big challenge certainly building with something like directly onto Lambda functions, where you do have a lot of different APIs you're interacting with or different services that you're connecting to, and trying to do that observability and know sort of what's happening. All these observability companies are amazing, by the way. They're all doing awesome work. But I love that idea of like just take all those layers of the stack. Like, is my thing working? Is it performing where it needs to? And then go to the next step and say, how can I optimize it, right? Which is that idea of like, well, maybe we deploy these to more edge functions or do something like that, or do some code splitting. And then the last piece is like, from a business standpoint, like, is it actually, giving me the value that I want from it? So interesting. But I think that the idea of auto instrumentation and just taking that away from the developer is another thing that gives you that instant feedback loop, hopefully, or that rapid feedback loop, and makes the developer experience, whatever that is, makes that better.
Yeah, I love the idea of the auto instrumenting too, and I think we're at a point now where the developer has so much control over these primitives and is defining their application at such a high level that we can get really good discrete information out just from the naming conventions alone. There's still, when we're integrating across a whole bunch of other companies, it's hard to know. We always blame ourselves, and then we find out GitHub's down, or like, Actions has been down a bunch lately, and it hasn't been great observability into when and why, and like, we'll be like, there's no way they're down. What are we doing wrong? And we're digging in further, and then it's like the notice comes up, and it's like, oh, seriously? Like, not again.
Corey Quinn and I walked by the Slack headquarters yesterday or 2 days ago, and I think we took down Slack. So I mean, it happens.
Just created a slight breeze, and servers blew up everywhere.
But I think you hit on a great point that both of you raised. I would tweak your question: is my application working? No, your application is not working. We're always building distributed systems, and distributed systems are always operating in a failure mode.
Right. Yeah.
And so it's is my system working ideally? Or is it working in the way that I expected? Because all of the aspects of the system under your control are working, but without the observability piece, you don't know that it actually was GitHub's fault.
Well, serverless also made everything backwards. So it did. So like in the old days, uptime was how we knew. Like I'd say, oh, did I get a 200 from my thing? Is it up? In this world where my function goes away, I don't want uptime. I want only invocations to happen when they're supposed to happen. Uptime for me is actually a negative metric. And so it's a weird world where now I want discrete errors, and I want good error boundaries, and I want good error reporting, hopefully through a dead letter queue that pumps into my Slack channel with a line number, so I know exactly what to fix and when. And that's a different mental model, because we're used to running these sidecars on these like monoliths that are spread out, and you have a bug somewhere, and that somewhere could be one of 50 servers in a fleet, and maybe it's only one of the servers because one of the servers didn't get patched right. And like it's a weird bug, and so you need to watch all these servers individually. And now we've got this new model where we're like, I don't want to watch anything. You tell me when you're broken.
Yeah. Right. And I think actually you both get into the same point, or at least what I think is the shift from reliability to resiliency, where we're essentially saying, like, you know, it's not is my application working or is it up and running? It's is it working well enough, right, in order to serve my customer? And again, because distributed, you know, everything breaks all the time, right? I mean, that is the classic line, and it's true. I mean, what we've run up against with like AWS control plane APIs, like my goodness, like. You know, AWS does a great job, but scaling their own control plane APIs, you know, there's a lot of rough edges there, and because it's a hard problem. I mean, you're working with distributed systems, right? So, you know, being able to do that is tough. But I think that's the big thing of it, is like, if there is something failing, you know, are you designing your systems in a way that allows part of it to load, right? So maybe I am getting some flashing gray boxes, you know, here, and because my personalizations aren't loaded because that particular thing is down, but you know, the core product stuff is loading or whatever, or there's a fallback. Like, I mean, even this, you know, the idea of rehydrating pages is great, where you could serve up a static page, like even if that page is 20 minutes, an hour out of date, may not be terrible as long as I can serve something to my customer, because I can't go ahead and rehydrate it. So, but again, those are design patterns that have completely shifted, you know, and being able to know when those things are happening is important. And we don't have time to get into chaos engineering, but I mean, that's another topic that is probably worth exploring later.
This is why I'm loving Remix lately, because we're starting to see, I think, the front-end community really re-embrace progressive enhancement, which is all about resiliency. People think it's about accessibility, and it is about that too, but it's also about giving your users an experience no matter what happens. And let's face it, shit happens. And you can't control the network. You don't know if that JavaScript got there. So having some kind of like reasonable HTML fallback is always a good option, way better than a skeleton screen that never loads.
We've got just under 8 minutes here. There's been a theme that I've seen weaving in and out of here, and it was actually, I had it separated into 2 topics. I'm gonna give them to you, and then let's just discuss as you see fit. There's been a lot of talk about conservation, right? You don't wanna measure an uptime. Uptime is waste. And that manifests itself in 2 ways. There's cost, and Simon Wardley said in December 2018, you're going to need a better name than environmental impact. And there is an argument that I don't think is made often enough, that serverless computing is better for the environment, especially with the release of things like the ARM Graviton 2 platform for Lambda, which was heavily adopted. So that actually does both. It saves you money, it saves the environment by drawing less energy into the data center. So should we be pushing the conservation issue, which I've heard throughout all of your responses, both financially and environmentally?
I think it will be an important part of what every cloud company have to do in the next 5 years, and so figure out like how do we actually understand the carbon cost of what we are doing, how do we allow customers to offset it, how do we use data centers and services that are sustainable, how do we measure that? I think the key problem around it that we're actually working with some companies on internally is figuring out just like how do we actually measure it, right? Like how do we actually understand the impact of different technologies? And it's extremely difficult, and there's a lot of companies now getting formed around like how do we measure that? But I think it will be an important part of like, it's probably the greatest challenge we face as a civilization right now. Like how do we get carbon neutral fast enough to avoid like a massive disaster? And all of us will have to play a role in that. And I do think that there's like inherently when we started thinking about like the Jamstack as pre-building as much as possible, right? Like obviously that saves just a ton of compute. It makes the system run a ton more efficiently. The more you can cache and pre-compute and not have to build over and over again, the the lower your CO2 emissions will just naturally be, right? Like, so I do think there's an architectural approach there that optimizes for using as little compute as possible. That will be a net positive thing.
Go. Yeah, that's right. Exactly. No, I think, but I think, yeah. Again, serverless
went there.
from a. I hope there's no Web3 fans here. From the pure, energy standpoint. I mean, we have to remember too that there is a big server running behind the scenes that lets us run our serverless function. So there's something like Spot. I mean, one of the things that was mentioned before was like Spot instances, for example, are just sort of ways that you can buy unused compute because those servers are running anyways, and it's not particularly easy for them to just shut down a bunch of servers. Now, if anybody's ever had to scale their applications in AWS, you know that it involves a lot of trouble tickets and letting them know, by the way, I'm going to need this much compute, because if you don't, it's possible that they don't have enough servers turned on to handle that specific type of workload. So even just knowing that there could be a spike sometimes requires them to spin up more servers in order to handle those things. So the actual cost benefit of it is, I don't think we're there yet now. I mean, we don't have servers that, when you pull up to a red light that the engine shuts off and then it starts back up. Those drive me nuts. But anyways, so I think there's not a huge impact right now on sustainability from running serverless functions. I think we'll get there. I think it's a better place to be now, but I think the amount that you're saving, it's like, well, I reused my napkin once. You know what I mean? It's minimal, the impact, but it's all worth it, and it's all stuff that we should be doing. And I think we need to get better. In terms of the cost aspect of it, though, I think if you're spending time trying to optimize your Lambda function right now, you are wasting a ton of time. Right? You're creating more carbon dioxide just by spending the time to do that than you are saving anything there. So I think the bigger costs are going to be moving data, your data costs through AWS. If you're storing things in CloudWatch for some reason, you're paying a lot of money to store things in CloudWatch. Those things get expensive. Those are better optimizations if you're really thinking about cost. So if you're already running on Lambda or you're running serverless applications, some of these managed services, you're going to see, I think, cost reductions depending on the type of workloads that you're running, and that's already an optimization there. But overall, sustainability-wise, I think serverless is the way to go, right? Using managed services, not building these things yourself that are running idle for no reason. But it's not quite the massive green revolution that we're hoping for. There's still a lot of work that these data centers have to do to get that.
I will push back on that just a little bit from insider knowledge.
Okay.
The amount of packing that you can do on average onto Lambda instances, EC2 instances that are dedicated to Lambda, is much higher than customers achieve at the mean.
Right.
Across all other workloads on EC2 for the same types of things. So there is actually a step function, almost 100% additional workload at the mean state in terms of what am I trying to say? Like in terms of available compute that's actually consumed rather than just burned for no reason. So there is a little bit more there, and then maybe this is a messaging thing that they're not saying that enough because they say it publicly but not emphatically.
They're just getting good at this. Last reInvent, they introduced a thing called the sustainability pillar into the well-architected stuff. And there's good writing there about how Amazon's approaching it. Amazon's got more money than God, and they're plowing it into data centers, and they're just building data centers everywhere. When you hear people talk about regions, you're thinking that, oh, that's a data center in a place. No. It isn't. A region is 4 data centers, at least in a place for redundancy in case of a catastrophic event, and they take care of replication in between those data centers. And these aren't just small data centers. We're talking like city block of computers, floor to ceiling. The idea would be that they're going to amortize that cost, and they're going to drive that cost down. They're going to hit a point where it's more sustainable for them to pack that thing than it would be if you're running it inefficiently yourself. And I think that's probably true, and I think there's also going to be a nice little fight between the big clouds on who's doing a better job of this. Because I know I want to run my workloads in the greenest way possible because I'm scared shitless about the future of the planet. So I think it's obviously correct that we should outsource this stuff, and it's obviously correct that we should try and be more efficient with this stuff, and over-provisioning is a bad idea, and we should do more stuff up front that we can, and more caching that we can do, the better. On the finance side, Jeremy's totally right. You will create more carbon monoxide mouth breathing than you will save trying to optimize your Lambda functions. I mean, these things are cheap. We're talking 10 cents for 1 million invocations, so you can be kind of wasteful with them because they, you can have a whole bunch in your account, and if they're not running, they're not running, and it doesn't really matter. Where you're going to get hit from a price perspective is going to be in your data, in DynamoDB or your logs, something like that. It is interesting. Simon's postulation was originally with FinDev that we'd be able to look at an application and know which functions made us money and which ones were a failure, and so we would have a way to measure our dev teams better. And it's kind of a terrifying prospect to me. And also, just on the cost basis, I mean, if a function gets invoked 3 million times and it's 30 cents, did that person do a bad job? I don't know. Like, it depends on how much money that function made, I guess.
Yeah. Or if that's your authorizer function, then it doesn't matter because it gets called for everything, and so it's important no matter what.
Yeah.
Matt, Jeremy, Brian, we're at time. Thank you so much for joining for this panel today. Appreciate it. Thank you all for joining us. We hope you learned something. I guess you will.
Give it up! Thank you so much, Rob, Matt, Jeremy, and Brian! Give it up, y'all! Woo! Yeah! All right, thank you so much to our panelists. What an amazing discussion. We will let them all go relax and get ready for lunch, which is also what we are going to be doing in a moment. But really quickly, first want to remind y'all that there is a photo contest happening today with prizes being given out before the last segment of talks. And that is a contest sponsored by PlanetScale. So to enter, swing by PlanetScale booth at lunch, take a photo, make your best selfie face, put it on Twitter, tag Reactathon and PlanetScale data, and if you are the lucky winner, you will be getting a prize later this afternoon before the last section of talks. All right, now we have lunch in the Upper Grove from our amazing caterers, Lifted Plate. Huge thank you to them. So everyone, please enjoy, and we will see you back here for more great talks after the break. Thanks, y'all.
Think about it. Think about it. Think about it. Think about it.
kick.
Think about it. 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 Think about it.
Should I be the swell in music?
So just send her now? Okay, you can go ahead and go.
Hey folks! What's up, my Lunch and Learn crew? Did y'all get some food? Yeah. Delicious, right? Yeah. All right, awesome. Well, thank you again to Lifted Plate for the delicious lunch. And now, because we don't just lunch, we also learn while doing it, we have a Lunch and Learn from the Director of Product Management at Hasura, my colleague. So pretty excited about it. He has so much great past experience in product, in engineering, in consulting, in all kinds of different things, and is going to be talking to us today about a pretty exciting new feature Hasura just launched, GraphQL joins. So we're going to be learning all about that. Please join me in giving a very warm welcome, and since there's fewer of us, we have to be louder. Please join me in welcoming to the stage Rishi Devte. Woo!
Thanks. Hey, thanks so much, Anjana. And today I'm going to talk about joining data across GraphQL services with Hasura. So as Anjana said, I'm product manager at Hasura, a bunch of experience in software engineering, consulting, and product management. So Hasura is in the space of accelerating your API development by creating a single GraphQL schema across your data sources. Okay, and I just want to get a quick show of hands. How many of you are familiar with GraphQL? Okay, so a bunch of you. And how many of you are familiar with Hasura? Okay, a few of you, cool. So today what I'm going to first do is talk about some of the challenges that we are facing with data access and how Hasura can help. And then I'll talk about joining data across sources, and then I'll wrap it up with some recommendations and pointers to resources. Okay, So let's talk about data access challenges. So as we all know, data powers apps, right? Imagine Uber Eats or DoorDash not having a database of drivers and restaurants, right? So this data can come in from a traditional database or an API, okay? And so when we talk about developing an app that uses a database, I'm just going to go through a quick development workflow, right? If you're a manager, you'd go ahead and approve the budget. If you're part of the database team, you're going to go ahead and set up the database. If you're an architect, you're going to design the microservices, interfaces between them. And if you're a backend developer, you'll go ahead and set up an app server to convert the models from your database to models in code, secure connections with the database, and develop an API layer so your front-end developers can get access to the data. And as you're doing so, you're going to continually optimize for performance. And if you're on the front-end side, like most of us over here, you're going to be responsible for creating your mobile and desktop visualizations. And finally, if you're a part of the DevOps team, you're going to be responsible for monitoring the entire application stack. Okay? So what we've noticed is this plumbing that backend developers do in terms of setting up an app server, setting up the API layer, optimizing for security and performance takes a ton of time, right? Furthermore, you have to do this for every new database, every new data source or app you develop, right? And given that data is essentially the keys to the kingdom, you have to constantly manage and maintain security. Every organization also has a production-ready checklist, so you have to make sure your app is optimized for security, availability, performance, and you have to build off all of this yourself. Right? So let's talk about how Hasura helps with this. So first, let's just talk about GraphQL. So GraphQL, as many of you know, open sourced by Facebook in 2015. It's an open API spec. Most importantly, it's a flexible API framework that allows you to do CRUD operations like your select, insert, updates, and deletes, as well as non-CRUD operations like aggregates and joins. You can query for data efficiently in that you are asking for only the data that you need. So if you, for example, want user ID and name, you can query only for those fields and get the results back, as opposed to getting 100 fields for a user object, right? And then because of this, what you can do is you can monitor which fields and attributes in any model are used the most. So you can optimize your app and database to create a better end user experience. Okay. The one thing though is this is a spec. So if you want to build a GraphQL API, you have to do all of the plumbing and the work yourself to convert your models from the database to the GraphQL schema. Right? And so that's where Hasura comes in. So what we do is we connect to any database, any REST API, or another GraphQL service, and we map the models, either database models or API resources, to our own logical schema, and then determine the relationships across those models to generate a single GraphQL API endpoint. Right? And we package in security, availability, and performance features so you don't have to do all of this yourself. So in terms of development, what we're really doing is we're getting rid of these two app server and API layers, right? And what that means is it's significantly reducing the amount of time it's going to take you to develop this app server and API plumbing. Okay. Furthermore, we've seen this being used in two scenarios. One is if you're developing an app from scratch, what we call greenfield app development. It can help accelerate your development time, as I just talked about. Also aligns with the new application trends that we've spoken about earlier this morning: Jamstack, microservices, serverless, and GraphQL as well. The second use case is if you're a database, data infrastructure, or platform team, and you want to provide data access to a bunch of your application development teams, you can replace that with this API as opposed to providing direct database access. Right? So this also aligns with trends in the data arena, where we've seen a huge number of databases coming up. We've seen database as a service, and also what we're seeing is this need to share data across teams within your organization or outside of the organization. Okay. So we've seen these two use cases resonate with a lot of folks. We launched our open source project in 2018. We've seen 500 million downloads, 26,000 stars on GitHub. We've seen a lot of adoption from developers in startups, mid-sized companies, and larger companies. We also launched our Enterprise Edition and Hasura Cloud products in 2020. So we are 120 employees. We're headquartered in San Francisco, globally distributed, fully remote culture. We have employees actually in 5 continents today. Okay. So now let's talk about an advanced use case when you're combining data across sources. Okay. So application development organizations, they like to divide and conquer. So one team will develop one piece of the puzzle, another team will develop another, right? Same thing with GraphQL APIs. Just like you would use, you would develop microservices, right? For scalability, troubleshooting, maintainability, and so on. So the one thing is, if you have multiple GraphQL APIs and you want to combine related data, you have to write custom code. Each of these GraphQL APIs, you can do all kinds of queries, CRUD queries, as I was saying earlier, and they return different data types and different JSON arrays for each query that you do, right? So when you have to essentially write custom code for each combination of these queries that you're doing, right? And that can take significant development time. So what we're introducing today is our GraphQL to GraphQL joins, and this furthers our goal to accelerate API development. And we're doing this, again, through a single GraphQL schema across these multiple data sources. What we are also doing is making sure that this is 100% compatible with with the existing GraphQL spec that's out there already, right? So you don't have to modify any third-party services that you integrate with, like Shopify and GitHub. Okay? So what I'm going to do now is just show you a quick demo. Let me get my cursor. Okay. So what I'm showing here on the screen is the Hasura console, where you can configure Hasura and use an API Explorer to test out your APIs before you hand it over to the application development team. Right? So here I'm showing the API Explorer, and at this point, I haven't really connected anything to Hasura, so it shows that I can't make any queries. Right? Now I'm going to go ahead and add a remote schema, and a remote schema is essentially another GraphQL API service. Okay, so I'm going to go ahead and add a store remote schema and assume for a second that I have an e-commerce app, and this store GraphQL API service stores all the orders that have been placed in this e-commerce app. So what I'm going to do is put that in and then plug in the URL and add the remote schema. And that's it. And as soon as that's done, I can query all the data that's available in the schema through this API Explorer and outside of it as well, right? So it shows items and orders that this schema provides. And then I'm going to go ahead and add another remote schema, and this time I'm going to add a fulfillment remote schema that keeps track of all the orders that have been shipped. Just plug in the URL and add that remote schema. Now what I want to do is I want to do a join between these two. And the reason I want to do it is I want to see the items that have actually been shipped in my fulfillment schema, right? So the fulfillment schema just shows that, hey, this order has been shipped. It doesn't know anything about the items that were shipped with that order, right? So I want to establish that relationship. So I'm simply going to add this relationship from fulfillment. I'm going to give it a name, order. Select the source as fulfillment. Select the target reference as store. And then I'm going to select a key on which I can join the two. Here I'm going to select ID. And I'm going to essentially tie the order, the ID field in the fulfillment to the order ID in the store. Okay. And I add the relationship, and as soon as I do that, and I expand my fulfillment schema, in my API Explorer, I can see that I have order associated with every fulfillment ID, right? And then if I expand that out, I can see the item name, the price, and the quantity under the order, which is again under the fulfillment schema. And so I can make a query now that says, okay, give me all the items that were shipped for our order ID 10, right? So this is what the GraphQL query looks like. And this is the response that tells me that this item was shipped in this ID. Okay, so it's as simple as that. We don't have to go ahead and modify any of the existing remote schemas. Okay, so now what I'm going to do is add a few permissions. So now we are going to add a new role called a clerk role, and I'm just going to initially give them all permissions. And I'm going to do that for both the fulfillment and for the store schema. And then once I go back to the API Explorer, if I log in with the clerk authorization token, I can see all of the data on the left side. So I'm giving them everything just like I did before. So you can see everything that I saw before with the admin key. And now what I want to do is I want to go ahead and remove a column so they can't see, for example, a specific column in the store schema. Right? So I'm going to go here and just deselect the quantity column, save permissions, go back to the API, and then if I expand it out, I can see that the quantity doesn't show up anymore, right? So it's automatically hidden. Nobody can access that column. Okay. So again, all of this is done without touching the underlying API, GraphQL API service that is providing this information. Okay. So that's the demo. And then similarly, we can also do joins across other data sources. For example, you can join a GraphQL API with another database using pretty much the same interface, right? All of the same benefits as before. And yeah, you can generate this single unified GraphQL API across all databases and other GraphQL API services. Okay. I'm just going to summarize a few recommendations based on what we just talked about. And this is regardless of whether you're using Hasura or not. So first of all, we've seen that GraphQL really helps accelerate the data access challenges that we were talking about earlier. And it helps accelerate greenfield app development. So if you're developing an app from scratch, we've noticed that you can really accelerate your development time. And then if you are responsible for providing data access to other application development teams, it can help in that regard as well. Now you can always build multiple services for data access if needed, right? So divide and conquer just like you would do while building any kind of microservices. And then to combine all of them together, you should federate across these data sources to build powerful apps. Okay. All right, so now I'm just going to point you to a few resources that we have on our website. You should check out our website for downloads of our community edition product, free downloads. You can also sign up for a free Hasura Cloud account. We also have all our technical docs out there. We have the Hasura community. Highly recommend you join our community. We are on Discord, GitHub. We have a monthly newsletter. We also have a monthly community call where we talk about all the new features that were announced in that month. And we also have someone from the community talk about their use case. Okay. And we also have, we're hiring. We have a fully remote culture. Our front end is in React and TypeScript, if you're interested. And we also have a user conference coming up at the end of June, HasuraCon. So feel free to register. It's online and free. Okay. Right. So that's all I had. Feel free to reach out to me if you have any questions. Thanks, everyone. Thank you.
Please keep it going for Rishi. Hey, thank you so much for all the lunching and learning, Rishi. All right, so we are a little tiny bit ahead of schedule. So we're going to I'm going to take my mask off because I've been wearing it all day for safety first. And we're going to let folks trickle in from the lunch. If folks haven't had a chance to say thank you to our amazing caterers at Lifted Plate, please do. They're doing such good work. They're working so hard and feeding us, right? And it's delicious food. So please give them some love if you haven't already. And we will be back here in a few minutes with our next speaker to get our post-lunch talks rolling. So sit tight. We will be back with you in a couple of minutes. Thanks so much, folks. And welcome back to Serverless in the Park. Woo! Yeah, that's right. That's right. Thank you, friend. That's right. Come on, folks. Are we not excited for more learning happening now? Yay! Woo! Woo! Awesome. 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 Hope everybody got fed and watered and ready for their brains to keep working, because that is what is about to happen here. We have a small change to the previously scheduled broadcast. We are going to have a special surprise speaker jumping in for our scheduled speaker, Farah, who is not able to make it today. But the awesome part is we are going to hear about the evolution of a Redux async logic from none other than Redux maintainer himself, senior engineer at Replay, and amazing impromptu teacher of evolutions of Redux async logic for all of us here lucky enough to be graced with this surprise talk. So please join me in giving a very warm and very excited, energetic, not food coma welcome to Mark Erikson! Woo!
All right.
right. Good afternoon. Thank you all for being here, especially right after lunch. I know how hard it is to actually try and pay attention to things. My name is Mark Erikson, and today I am very happy to be talking to you about the evolution of Redux async logic, a topic that is very near and dear to my heart. Heads up, these slides do have a lot of words on them, which for anyone who knows me is not terribly surprising. Don't worry about taking notes. I do actually have the slides already up on my blog. I'll show the link to that in a second. And of course, the remote decides to quit right when I come on stage. All right, podium it is. So, who am I? I am a senior front-end engineer at Replay, where we are building a time-traveling debugger for JavaScript applications. We're actually one of the sponsors right now. You see our booth out there. If you haven't had a chance to come by and check things out, please do. It's an amazing app that I wish I'd had much earlier in my career, and we will very happily show you how cool it is. There we go. Outside of the Replay stuff, I spend a lot of my time answering questions about React and Redux, basically anywhere there is a text box on the internet. I collect links to any and all articles that look useful and interesting. I am a writer of very long blog posts, and I am a Redux maintainer. I created Redux Toolkit, wrote React Redux versions 7 and 8, and have written a lot of our documentation. But what most people really know me for is that guy with the Simpsons avatar popping up pretty much everywhere. So let's talk about Redux middleware. What are middleware? Middleware are an add-on for Redux stores that provide an extension point between the time that you dispatch an action and the time that the action reaches the reducers and is processed to create the new state. And middleware are generally used for two major kinds of use cases. One is centralizing application behavior, like logging or analytics, and the other is giving users a way to plug async logic into the Redux store with their choice of syntax and APIs. So, continuing the theme of quotes from people on the React team, Andrew Clark and Dan Abramov made some comments way back in 2015 about why Redux has middleware in the first place. And Andrew said that we didn't want to require Redux users to use one single approach for async logic. We wanted to build a baseline that other people could plug in their choice. And Dan similarly said, we don't want Redux users to have to learn a complicated library like RxJS. So we wanted to keep it more simple and flexible. So how do middleware work? Middleware form a pipeline around the Redux store's dispatch method. In fact, if you have middleware added, when you call dispatch, you're actually calling the code for the first middleware in the pipeline. You can kind of say that middleware can teach the dispatch method how to process other values that are not standard Redux action objects. You can use them to transform values like a function or a promise into a Redux action. So a middleware really can do anything that it wants whenever it sees an action or some other value going through the pipeline. It can look at the action, it can log it, pause it, modify it, stop it from going forward. Because middleware have access to dispatch and get state, and they can see all the actions going through the pipeline, this makes them a good place to manage some kind of a persistent connection like a WebSocket. So how do we write middleware? Well, Redux was designed using functional programming principles. And so middleware worked the same way. The code can look a little bit complicated. A middleware is written using 3 nested functions. The outermost function gets dispatch and get state together in an object. The second function gets a reference to the next middleware in the pipeline. And the last function is called every time an action is dispatched. And it's the one that does the actual processing. So there have been hundreds of Redux middleware that have been written, many that have been published on NPM, but there's a few middleware that have really been standardized by the community over the last few years. And by far the most popular of those is the Redux Thunk middleware. The idea of thunks is that instead of passing an action object into dispatch, we pass in a function. And the thunk middleware sees that this action is actually a function instead, and it calls it and passes in dispatch and get state as arguments. And this allows us to write code that can interact with a Redux store without knowing ahead of time which Redux store it will be talking to. And inside that thunk function, you can now write whatever sync or async code that you want to. This is really good for complex synchronous logic that needs to do things like reading state or dispatching multiple actions, and some moderately complex async logic like your typical AJAX data fetching. Now, like all tools, this has trade-offs. The good news is you just write some fairly simple functions, and they can have any logic you want. But on the other hand, thunks cannot respond to dispatched actions. They're very imperative code, and you really can't cancel a function once it starts. It's just a function. It runs start to end. The second most common middleware is sagas. Sagas use ES 2015 generator functions, and these are very different because they don't do the actual work. They return descriptions of the effect that's supposed to happen, like go call this function with these arguments, or go select some data from the Redux store and wake me up when it's available. The Saga middleware does the actual work, processes the data, and wakes up the generator function later on. Now, the Saga library has some very powerful effects APIs that you can use to implement like background thread type behavior or debouncing and canceling. So the trade-offs for sagas are, in some ways, they're a lot more testable because I could call my saga and just verify that it returns the right descriptions of effects without having to make actual AJAX calls or something in my tests. On the other hand, generator functions are very complex. I still don't grok all the behaviors, and you have to understand the specific effects APIs from the Saga library. And the third most common async middleware is observables. Observables solve some of the same use cases as sagas, but they use the RxJS library for processing instead of generator functions. Parallel to the idea of sagas, our Redux observable calls these pipelines epics, and you use normal RxJS APIs to define the processing behavior. This has the same use case as sagas, very complex async processing pipelines. So you can do things like, when this action is dispatched, go fetch this data, transform it, maybe delay it, and then dispatch another action. Now, the good news about this is that RxJS is not specific to Redux. It's very common in the Angular world as well. So if you know RxJS, you can use that same knowledge across multiple libraries. On the other hand, RxJS can be very, very complex, hard to understand as a mental model, and frankly, pretty hard to debug as well. You can't just pause the code in the middle to see what's going on. I do have a bonus slide that I added late yesterday. So David Khorshid was talking about XState and side effects, and David has written a couple articles about how Redux is only half a pattern, because you can write Redux reducers as state machines, but in practice, most of them don't fully match that approach. Well, it turns out that you can use XState to create true state machines and then use those as reducers in the Redux store. It's great, it works. And in fact, one of the stately devs, Matt Pocock, recently created a proof of concept where he showed how to take an XState state machine, plug it in as a reducer in a Redux store, and then use xstate to manage side effects. So this is a thing you can do with Redux middleware. And in fact, yesterday, Dave and I were talking, and we'd actually like to turn this into like an actual integration package of some kind. So 3 years ago, we released Redux Toolkit, which is our official standard API for how we want people to use Redux code today. It includes APIs that simplify all the standard Redux usage patterns. So Redux Toolkit builds in support for thunks in a couple different ways. One is that the configure store API automatically adds the thunk middleware to your store setup, so you don't have to do that yourself. We also have an API called create async thunk, which standardizes the typical pattern of dispatch an action before you make the request, and then dispatch another action for success or failure after the request comes back. This is because thunks have been the most popular approach. We've also really recommended thunks as the standard approach for years now, and there's a few reasons for this. By far the most common form of async logic in Redux is fetching data from a server, and thunks are the simplest way to accomplish that. We've really recommended against using sagas for basic data fetching. It's kind of like a chainsaw. Like, if you really need a chainsaw, it's nice to have one, but you don't need a chainsaw on a daily basis. It's just too much power. And kind of the same thing for observables. They're very, very powerful, but they have a lot of capabilities that you don't need in a typical application. So, last year, we added a new piece of the puzzle. We added a new API called RTK Query to Redux Toolkit. How many of you have ever used React Query, Apollo, or SWR? Okay, a lot of hands. Over the last few years, we've seen that the React ecosystem has changed from state management as the problem space to data fetching and caching. How do we keep our our state from the server in sync on the client? And this is really a different thing than client-side state management. Tools like Apollo, SWR, and React Query are purpose-built for that use case. I've seen Tanner Lindsley, author of React Query, retweet people saying, like, I switched to React Query and I deleted 5,000 lines of Redux code. And frankly, he's right, because you had to write all that code by hand to fetch data. So RTK Query is our tool that solves that same problem. It's included in our Redux Toolkit package, and it abstracts the data fetching process completely. You define a set of endpoints, which could be GraphQL, REST, or basic, just random async functions, and it auto-generates React hooks you can use to fetch that data. It is UI agnostic, so you can also use it with other frameworks as well. And the great news about RTK Query is that it can completely eliminate the need to write any thunks or reducers or use effects to fetch data in a React Redux app. So how do we use RTK Query? Normally, you would have one API slice definition in your app, but you would define many different endpoints inside. RTK Query is a non-normalized document cache, which basically means whatever the server sends back is what it saves in the Redux store. But you can reshape the data as it's received on the client. You can also pick out specific pieces of the data from one of those responses. So maybe you fetched your whole list of to-dos, but you could grab out just one entry in a component that needs it. We also have some very advanced features in here. For example, maybe you've got a chat application and you want to fetch the initial list of messages via AJAX, but then you want to stream all the additional messages over time over a WebSocket. And RTK Query has some lifecycle options that let you do that. Also, another late addition to the slides. Yesterday, Ryan Florence was showing off React Router v6. and he pointed out like fetching data in parallel via the new loader prop in the route component. Because these are just standard Redux thunks under the hood, you could, in theory, I'm just basing this off the slides yesterday, initiate the fetch by dispatching an RTK query thunk in the loader prop, and then read the data with a hook in the component, and it ought to, I hope, fetch all that data in parallel. I'm guessing, but like I think this is the way the pieces would fit together. A couple months ago, we released Redux Toolkit 1.8, and this added a new API that we call the listener middleware. Redux Toolkit didn't have a way to respond to dispatched actions. You either had to write your own custom middleware, or you had to use something heavier like sagas or observables. So this was a use case we wanted to handle ourselves. So this new listener middleware provides an API that solves basically the same use cases as sagas or observables, but with a much smaller bundle size and hopefully a much simpler API as well. And one comparison I like to make is that it's a lot like React's use effect in terms of this thing changed, go run some code, but it's for Redux store updates instead of React components. The listener API also includes some primitives that you can use for more complicated async logic as well. So again, trade-offs. The good news is it's built into Redux Toolkit. If you're using RTK, it's available for free. Also, you're using async await or just basic synchronous code rather than generator functions, so it's probably simpler to write and use. In fact, it's very similar to writing thunks conceptually. Another thing is like sagas don't work well with TypeScript. Generator functions are kind of hard to type, and this should work very well with TypeScript out of the box. What are the downsides? Well, it's pretty new. I cannot claim this is battle tested, but we did evolve the API and try to work out like what are the use cases people need to solve. And there's probably a few cases that sagas or observables can do that this might not be able to handle. So how do they work? A listener entry can match against a single action type, multiple actions, or even possibly checking state conditions as well. So maybe you only want to run the code when like state.counter.value is greater than 3, or when it changes from 2 to 3. We've got some primitives like condition and take, but these APIs are cancellation aware, so if your listener effect is paused waiting for something and you cancel the listener, it'll just bail out. They also have APIs for further subscription management, like I can unsubscribe the listener as a whole once it starts so that only one copy can be running at once. And you can even fork off little child tasks as well and wait for those to return a value. So, what are our recommendations today? I've honestly been a little surprised how much this sort of question comes up. I've had people at the conference just in the last couple of days asking me like our app uses sagas, but they're really complex and we're having trouble making them coordinate back and forth. Or like, what tools should I use for these problems? I'm a very big believer in trying to understand what is the purpose for a given tool, what is it good for, what is it not good for, to understand when I should use a certain thing. So our recommendations are really based on what problems are you trying to solve in your app right now. So if you're trying to do general purpose data fetching, my users, posts, to-dos, whatever, we recommend use RTK query as the default. It should solve the vast majority of your data fetching use cases out of the box. If for some reason RTK query does not do everything you need to, then you could use like create async thunk, or in the worst case, write thunks yourself. But please, don't use sagas or observables just for basic data fetching, you really don't need to pull out that chainsaw. If you need to write code that is supposed to respond to actions or state changes in the app, use the new RTK Listener API. It should work for the vast majority of cases that you have there. If by some chance the API isn't flexible enough, then fall back to sagas or observables. But honestly, my estimation is like only 1% of Redux apps should be using those today. And finally, if you just need to write some code that has access to dispatch and get state, use a thunk. It doesn't have to be the create async thunk API specifically. And in fact, my current day job at Replay does a lot of this. Our app is not a typical CRUD app. We've got a WebSocket API that talks to the back end, receives a lot of data, and we've got code that needs to look at the current state to figure out what it needs to do. So we have, I had to count at one point, roughly 185 thunks in our code base. And most of those are, these are not your like fetch async data, show a spinner. These are fairly complex sync and async logic. And so thunks are the right tool for that job. All right, hopefully that gives you some idea of the different techniques that you can use for async logic in Redux, how some of these patterns have evolved over the years, and what we recommend today. So our recommendations, again, please use Redux Toolkit. If you're not using Redux Toolkit and you're still using older style Redux patterns, the good news is you can migrate incrementally, and I am happy to talk about that. But please use the APIs in Redux Toolkit. They will simplify your code, and they should make working with async logic a lot easier. Thank you very much.
Keep it going, folks. Thanks so much. Woo-hoo-hoo! All right. Yes, so thank you so much, Mark, for that excellent surprise talk. Hope we are all feeling D-food coma. Yes, now that our brains are working. Yes. Totally. I can hear and feel from all of you the immense amount of energy that's happening. Yeah, woo! There we go. All right, so we have another great talk coming up for you before we take our afternoon break and get recaffeinated. Hope everybody has had a chance also to enter that photo contest. Don't forget, that's coming up later as well. And between now and our break, we are going to be learning about state machines on the edge. Do you realize how hard it has been for me to not sing Living on the Edge in my head all day, every day? It's so hard. Anyway, and we are going to be hearing about those state machines on the edge from author of Redux Form and React Final Form and developer at Centered, working on the best productivity app for developers. Please join me in very excitedly welcoming to the stage Erik Rasmussen. Yeah! Woo!
Hello, everyone. Let's see here. My name is Erik Rasmussen, and today I'm going to be here talking to you about visually coding backend logic using state machines. So before I get too far, what are state machines? Not everyone knows what a state machine is. So a state machine defines an initial state and a finite number of other states. That's why they're called finite state machines. And events to transition between the states. Okay? Now, on the front end, typically what happens is you will instantiate a machine, and as the user interacts with the UI, events are sent to the machine, and the machine will then transition into a new state. And if you're using a lovely declarative UI framework like React, it makes it very nice to change your UI as the state changes. Now, and also, like, machines are generally on for the lifetime of the component or the page. Now, on the back end, things are a little bit different. like normally a state machine will have a final state, and that means that once you get to that state, the state machine sort of shuts down and it won't receive any other events. You can't leave a final state. It's like a black hole sort of. On the back end, however, we have to be able to stop at certain states. Now, I'm calling these pause states. I don't know if there's a proper word for that, but that's the one I've come up with. So as your state machine is transitioning between states, on some states, not all states, you need to be able to, you need to stop execution and deliver back to the client the data. And like as I said, not all states are pause states. Sometimes you're going to want to transition into a state where you're waiting for some async data to come back, and then or say you're logging in, right? You go into the authenticating state, and then you're checking with whatever service, and then from there you transfer into authenticated or not authenticated states. And we also have the problem of where to persist the machine. Like on the front end, the machine is just sort of there in the browser, in the browser's memory, but on the back end, because serverless and because HTTP is stateless by design, we have to have some way to maintain the machine between requests. So there's several options. You can put it in a database, or in some sort of session store, or like in Redux or something. Or because I'm going to be using Remix for my demo here, I'm going along with their way of thinking and embracing the platform, and I'm going to use just the humble cookie. And everybody likes cookies. And we also have this thing that in computer science is called the halting problem. The halting problem states that you can never know if a computer program is going to return anything, if it's going to finish. You can't know if you're in an infinite loop or if it's just taking really long. So when you're doing state machines on the back end, you absolutely must set some sort of a timeout. You can't make the user wait, and you can't burn all your cloud credits just spinning around, right? So my favorite state machine library is Xstate, and they just released a new API that helps very much with this, called wait_for. So with wait_for, so I wrote this function called async interpret. The regular way to interpret a state machine with Xstate is the interpret function, and I'm calling this async interpret. It takes the machine definition and a timeout. By the way, side JavaScript pro tip: if you have a variable that is a certain amount, that's measuring a duration, a certain amount of time, always put the unit of time in the variable name, because there have been so many bugs where, is this milliseconds or seconds? Or do you have to divide by 1,000? Anyway, just a side tip. It also takes the initial state that we've deserialized from the cookie, and potentially an event. If the user has sent an event, then it will give that to the state machine. So we instantiate the machine to create this service that we can then start with our initial state. And if we have an initial event, then we're going to give that to the state machine. And here comes the important step. We're going to await this wait_for call, which obviously returns a promise. We give it our instantiated machine, and we give it our timeout, and then we give it this predicate. And this, when this predicate returns true, the promise is going to resolve, and we know that we can give our data back to the user. But if it returns false, it's going to keep waiting until the timeout comes out, until the timeout times out. And this is going to be called on every state transition. So we might transition 20 times into different states, checking this predicate every time. And when it returns true, then we're going to release our data. And here I'm using state.done, which is what is true when you've reached a final state. But also, I'm checking if my state has this tag that I've called pause. There's no first-party mechanism for this yet, but I've tagged all of my states that I want to be pause states as having paused. So that's it. Now we can safely run our state machine on the back end. Let me talk a little bit about the architecture that I'm going to be using. Each state is going to be its own route, okay? And if you think about it, routers are sort of fundamentally state machines, right? You're in this route and you click a link, which is a transition, and now you're in this other route. You hit the back button and you go back to the previous route. And speaking of the back button, it's absolutely fundamental that we do not break the back and forward functionality of the browser. Users really need that assumption. And it's not just back and forward one step, it's all the way to the history and all the way into the future that the browser knows about. And the way we're going to do this is with a global go-to event. Our state machine needs to be able to go to any state that the browser thinks the current route is. And our state machine is going to be serialized to a cookie, and we're going to asynchronously interpret our machine using that function, and we're going to send events as form data. This again is like it could be Ajax, but because I'm using Remix and I really like where they're going with just going back to basics with the browser functionality, we're going to send our events as form data. And the way we do that is with a form. So we're going to use Remix's form component, and we're going to set the method to post. And we're just going to use a regular old HTML submit button. But many people don't know this. You can give your submit button a name and a value. So this, when sent to the server and as form data and then parsed into JSON, is going to look like this this shape that is exactly what XState wants for an event type. But what if we need to send extra payload with our events? Well, for that, we can use a hidden input. I have not used a hidden input in at least 15 years. Back in the good old days, we used to have to use hidden inputs all the time to remember what ID of record we were updating or whatever. But they still work. And so there you can set any name and any value that you want. And that will, when the form data is parsed, it will be part of the JSON. And of course, we just submit the type of event the same way. So let's talk a little briefly about XState syntax. Guards are predicates to determine if a transition is possible. Sometimes you're in a state and you get an event, and you could make a transition, but you need to check with the current state of things if that's possible. Actions are side effects that can be executed, such as saving data to the context. And this is not React context. This is XState context, which is like a local storage inside the machine. And services, which are the way you asynchronously communicate with the outside world. OK, now it's time to attempt some visual coding. Let's see if this works. Down. Okay. Ooh, that is tough to see in the sunlight. Well, this is a state chart. This is the visual editor that the Stately team has put together for editing for editing state machines. And it looks really complex, but it's really not. Let me walk you through by simulating. This is a way to sort of walk through what the state machine would do. So this little guy here means that this is the initial state. So I'm doing a little checkout thing. So we start off in the cart, and we can receive these actions that keep us in the same state, but fire off. We can receive these events that fire off these actions. And if we open this up, if I click increment product a bunch of times, we are still in the same state, but we're running this increment product action. And decrement, same thing. If I do checkout, here I have a guard. Only if I have items, then I'm going to go to shipping. And from shipping, I can go back to cart if I want, or if I go to next, then I'm in billing, and if I can go back or next, or say I go in the back button all the way back to cart with a go-to event. So you can sort of get a feel, and you can allow the less technical members of your team to play around with the logic and see how the logic that you've built is working. And this is not a thing that is going to go out of date from the actual code, because this is generated from the code. This state chart is sort of bidirectionally linked to the actual state machine definition here. So and then we place order, and this is going to throw out, and this is going to initiate an async call to actually save the order in the database, and then order is placed, and this is a final event. Form, it's one of those submit buttons. It's one of those submit buttons with the extra payload on it, and this is, I can increment this and decrement that. I can proceed to checkout, and I can go back to cart, and notice my my route is changing here. But here I don't have any states yet, because this is what I'd like to demo of how I can add a piece between the cart and the shipping. So what I want to do is I have, say depending on which things you've chosen to purchase, there's different shipping states you can use. So what I want to do, if I can see in the sunlight here, oops, is I'm going to create a new state, and I do that by clicking up here. It appears here, and I can drag and drop these guys all around. I'm going to call this loading shipping states. And so when I click checkout here, normally it goes directly to shipping, but I can grab this guy and say, now I want you to go here. Okay? And when I'm in here, I'm going to invoke a service called load shipping states. So now I'm invoking a service, and my load shipping state is going to give me back an event when it's loaded, and when I get that, I want to go to shipping. Okay? This is a good default, but this is not the way I'm doing it. I'm going to use an event, and I'm going to call that shipping states loaded. But my shipping page isn't going to know what my shipping states are unless I save those loaded shipping states to the context. So here I need an action called save shipping states. Now the actual code for these I've already written. I can show you that perhaps. So now when we go from checkout, when we are in the cart and we hit checkout, we're going to go briefly to this loading shipping states state, which is not a pause state. And when it's loaded, then we're going to go to shipping state, which is a pause state. So I've just done that, and because it's remix, it's already hot reloaded. And so now if I press proceed to cart, it's going to wait a second and then come here, and I have my states. Okay? So I'm going to check out. I'm from North Carolina, and my save shipping action is also saves to the billing information, but I don't want to pay for this. I'm going to make can't pay for this. He lives in Utah. And so I can go back and forward just fine. Oops, except my save overrode Kent's thing, Utah. And I can place my order, and it's going to take a moment to place the order, and I place my order. So let me demonstrate that this is, Lord knows if you're going to be able to see that. This is entirely, so that had JavaScript enabled. Now I'm disabling my JavaScript. So nothing up my sleeve. Add some of these guys here. This is all working with no JavaScript. This is all going back to the server and coming back. Proceed to checkout. Takes a moment to load my states. And I do the same thing because I want even more swag. And I think Kent's going to buy me this one too. Utah. Place my order. Boom. JavaScript totally disabled. So let's briefly go over. Where's my screen here? So let me briefly recap what we just built. We had these pause states. Actually, let me go and demo. Let me go back. I've got time. Oops, not focus. So let me show you that the forward and back buttons work just fine, right? So I'm here, go to checkout, whatever, and up here, I can go back, forward, and I can go back several. Oops. So you can see that because we're using this go-to event, it's working just fine. All right. Okay, so we use pause states as routes, and we had these async states that were when I'm fetching data, where we don't return to the client yet. They're waiting until we get to a pause state, but if we had timed out, then we would have been able to handle that. We have a timeout to ensure that we don't wait too long. And the browser and back and forward buttons work with the go-to event that I just demoed. And we're sending events using form data. That we don't need JavaScript to do that because HTML does that for us. And we have this lovely visual design tool that we can drag and drop stuff, and it's easier even with technical people that can understand the JSON structure of a state machine definition. Even for us, it's easier to understand, to communicate with the visual tool. And there was no front-end JavaScript required. So thank you very much.
Keep it going, yo! Woo-hoo-hoo-hoo! Give it up for Erik and Martin, all our amazing speakers so far. Thank you so much. Yeah! That means that it is time for more coffee. It's break time. We are going to take a break before we come back for the afternoon talks. Remember, there is a contest going on sponsored by PlanetScale. Who entered? Who entered so far? Okay, well, we all better get those hands up after we come back. This is your last chance. Head over to the PlanetScale booth, take the selfie of your life, put it on Twitter, tag Reactathon, tag PlanetScale data, and we will be announcing the winners when we meet back here at 2:30 for our afternoon talks. Alrighty, see you there, more caffeinated. Thanks, folks.
Think about it. Think about it. Think about it.
bass kick.
Think about it. 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 Think about it.
kick.
Think about it. 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 Think about it.
up, y'all? How we feeling? Woo! Yes, I like to hear. Excellent, excellent, excellent. All right, well, I hope everybody took those selfies and tagged Planet Scale Data and Reactathon, because we are going to be announcing those winners after our next talk. But let us get going with our final set of talks for the day. Oh, and for the week. Oh, no. I know it's sad, right? I mean, I'm a little sad. But also, it's exciting because we have 3 more excellent talks coming up for you today. And starting things off with this section, we have the head of DA at Fauna, previously DA at AWS on Serverless, previous SaaS co-founder, and previous host of our awesome Jamstack and Serverless panel earlier. Who saw it? Who saw it? It was a great panel. Such a great conversation. And so here, back on stage, giving a humdinger of a talk about building data-driven APIs at the edge, please welcome back Rob Sutter!
Hi, it's me again. I see you found out about my talk. Thanks. This is building data-driven APIs at the edge. Here's what I hope you take away from today, right? What is the edge? How is it different from traditional serverless computing? The models that you might know already. How are edge functions different from single region serverless functions like AWS Lambda that we'll use as our example? When should you choose an edge workload? Like what types of use cases might you have where you should say, hey, I should be looking at this? And how do you choose a data store to support this data-driven workload? And then I'll give you a little bit of a note about authentication at the edge, some things to think about. It's largely similar to a serverless application, but there are some built-in benefits that you might not be aware of, and we'll touch on them real quick. So, again, who am I? Not Derek Zoolander. I am Rob Sutter, head of DA at Fauna. All that's been explained to you. The one thing I do want to point out from here is that our startup, Workphone, focused heavily on web and mobile users around the world. So we didn't know where they would be. They traveled, and they were in multiple countries to start with. So something like this would have been great for us at the time. We didn't have it. We had to build it ourselves. Ask me how all that undifferentiated heavy lifting went when you come visit me at the booth. So what are APIs at the edge? Not this. This is your traditional single region cloud architecture application. It's Amazon API Gateway. It's AWS Lambda. It's DynamoDB backing it. Something that you've probably seen before, right? And the advantage of this is you've got everything in one place in a single region. But when you get to the edge, you have, take for example, Cloudflare's POPs. They announced this week their 275th point of presence. And every single one of those POPs, every single one of them has servers running Cloudflare workers in it. So you can see that not only have you gone up to a distributed system, but you've gone out to a distributed system at massive scale. They're everywhere, including places where you can't get current cloud service provider workloads today. So when you think about workers or edge functions versus AWS Lambda or traditional functions, there's a couple differences in architecture of the service itself that are going to impact whether you choose to use them. And so for the rest of this talk, I'm going to use AWS Lambda and Cloudflare workers as my examples because that's what I'm most familiar with. But these lessons will generally apply to the other cloud service providers as well. So the first thing to know about Lambda was that it was designed for single region workloads. Like most of AWS, it's designed to be in one place as a feature that reduces your blast radius if you want to have multiple versions for rollout, staggered rollout, or for DRBC. That's an option that you can build on, but the idea is that you start from a single region. So the service itself reflects a lot of principles around that. The isolation model between one executing Lambda function and another running Lambda function is handled by Firecracker virtual machines. If you're interested in the depths, I really encourage you to look at the paper. It's brilliant what they did with it. But they are virtual machines running in a hypervisor. So that's your isolation boundary there. They're long running. So currently you can get a workload and process it for up to 15 minutes. And this isn't your API workload, which depends on API Gateway, which has its own timeouts. This is, again, that single region that's more equivalent to a classic data center where you're running your line of business applications. And so you pull something from a queue or you pull it from an event source, run a heavy operation on it for up to 15 minutes and store your data. And with apologies to those of you who are used to EC2, which is really big, AWS Lambda instances, by comparison, are really big when you compare them to edge functions. Up to 10 gigs of memory, up to 6 vCPUs that scale with your memory, and up to 10 gigabytes of code if you use a container packaging format. So there's a lot of stuff you can pack in there, right? Compare that to edge functions like Cloudflare workers, where the constraints are part of the platform. The first thing to know is that they were originally designed to handle inbound and outbound HTTPS requests, right? So these are request and response mangling, was the original idea behind it. That makes it a different type of workload from what you would do with a Lambda function initially. The security isolation boundary for a worker is a V8 isolate based on the Chrome V8 engine, and that has some effects. Oh, I thought that was there. What that means, I'll back up a second here. Because it's a V8 isolate, that means that your workers are running inside the same process with other workers. The V8 isolate itself is the boundary over the resources, shared memory, that prevents things like cross-function access from happening. Now, whether that frightens you or encourages you probably depends on which of these patterns you're more familiar with, but it's just something to know about the two. Edge functions are extremely short-lived because remember that initial use case, right? HTTP request response mangling. So you get up to 50 milliseconds of CPU time. On Cloudflare, that's a bundled usage model. You can put some options in there that let it run longer, but not as long as Lambda. The thing to know about Lambda was it was wall clock time. So you have up to 15 minutes of clock time to complete the run of your function. Whereas with these, it's 50 milliseconds of CPU time. So if you do something asynchronous inside your function, that time stops counting. It's only the time that it's actually processing your workload, but it's still not a lot of time. And then again, these are very small environments, these V8 isolates. So look, I put it up there anyway. It's up to 128 megs of memory available for your function. So that's 2 orders of magnitude smaller than what we talked about with Lambda functions, right? You're not jamming a lot of extra things in here, libraries, instrumentation, et cetera. They're shared processes in a single VM. Again, that's your security isolation boundary. And there's only 1 megabyte of code limit for your deployed code, which means there's really not a lot coming in there. But the constraints enable a lot of creativity, right? So the constraints being a part of the platform restrict you down to the workloads that suit the platform. And we'll talk about that. There's some other changes to know about when you go to the edge out of a single region. When you build a single region application on AWS with AWS Lambda, you need to put an Amazon API gateway there in front of it until the release of Lambda function URLs a couple weeks back. But typically it's another thing that you have to manage. Again, because workers were designed to mangle requests and responses, that firewall aspect of it is already there for you. Or I'm sorry, the gateway aspect of it is already there for you. You don't need to attach something else to the request. The initiator of the function isn't an event, it's a request. So you're starting from the context of an HTTP request object. Typically, across providers, it's only JavaScript, period. No exceptions to this. And largely not even Node.js because it's the version of JavaScript that runs inside that V8 isolate, not a 10 gigabyte version of Node.js with the standard libraries and everything else that runs inside a Lambda process. You can do tricky things here. You can run WASM. So you can run workloads that compile down to WASM, like Rust. But you've got, like, not all workloads will compile down to less than a megabyte of total source. If you look at a language like Go that ships its runtime and memory management and garbage collector and everything else with the WASM, it's not going to fit in there. So you have to either hand code it for optimization, which is tough, and good luck to you if you do, it can be done, or use something like Rust that just compiles down simply and does all those checks at compile time. There are also fewer related services when you're looking at the edge. So when you look at an API that comes in, you have a user that sends a message in your chat app. It comes into your API gateway, it goes to your Lambda function, and your Lambda function calls Amazon Translate to translate that into all the languages of all the users that are in that chat before storing it into DynamoDB. You don't have this stuff at the edge. You can make those calls outside of the service provider, back to AWS, for example, from Cloudflare. But Cloudflare isn't offering all of these types of services. And again, that's just a constraint that narrows down the use cases that are appropriate for it. So what are those use cases, and how do you know if you have a good workload for using your data-driven API at the edge? The first is when time is money. And this is the classic e-commerce use case, right? All the studies, every 100 milliseconds of latency that you add to your request, 1% of your users will leave the transaction and not complete it, right? So if you have a use case where you're trying to move somebody through a payment or a purchase process as quickly as possible to avoid losing them, that's a good fit for this. If the speed itself, the responsiveness, the reactiveness of the application, the web and mobile application for the user is a critical component of the user experience, that's a good use case for an edge function because simply the speed of light distance isn't there and you've got these ultra light, ultra fast runtimes. Web and mobile applications, again, when you have users that are moving around, you get that more responsive feel. And interestingly for me, Internet of Things ingestion. So whether you have stable or moving IoT devices, but not industrial IoT stuck in a plant in a single location. If you have lots of IoT devices, printers activating themselves, Roombas coming online, all of these things are good use cases for the edge because you want something that's close to them to get that complete TCP connection done as quickly as possible and take the workload off the device, which has battery restrictions. So then which use cases are less appropriate? And you sort of heard me speak to one here, right? If all of your users are inside your company and that's where they access your application, then that sounds like something that should be in your data center co-located with your company or in a single region that's closest to your company. You don't have users all over the world. You don't have users who travel. If your application is that geographically centralized for whatever reason, then that's not a good use case generally for edge functions. And the other one is when you're generating internal line of business data. So this is more logical than physical, but if you have backroom applications that generate piles of data and you're doing something over them, it doesn't make sense to ship that data out to some POP, do the compute on a lightweight environment and bring it back in. This is what you want those meaty Lambda functions for. The big 15-minute 10 gigs of RAM, let them churn through all of that data because it's already right there where you've collected it. And so then the advantages naturally fall out of the use cases that are good. The advantages are you have a snappier user experience for your users, which should, according to research, result in more conversion, which should result in more revenue, right? So you have more user satisfaction with your application when you're targeting the right applications with it. And the disadvantages, similarly, fall out from the poor use cases. Again, it's not just not an improvement to push single region data to the edge. It's actually an anti-pattern because you have to push it back out somewhere and then bring it back in. So you're adding round trips when the whole point of this thing is to shorten round trips, shorten speed of light, distances that must be traversed before any compute is done. The other one, the big disadvantage, is data stores. This is the most difficult part of doing edge workloads. Data is tricky. We are all very good now at doing single region data on those single region applications that we talked about. We understand DRBC with them, we understand backups, but when you introduce things like geographical disparity of your data, if you have 275 possible places where your compute workload can run, how many possible places can your data be as well, and what does that look like? Are you gonna replicate it to 275 locations? The answer is actually maybe, and we're gonna go through these. There are three basic categories of choices that you can make, and I'm going to call them out, including some vendors that are here today. The first is a single region data store. Just go with what you know. You already have your data there. Maybe the responsiveness isn't the thing, it's the constraint itself, or maybe your cache patterns allow you to use other solutions, and so you just stick with a single region data store. There are multi-region data stores, which are what they sound like. These are either in multiple data centers if you have your own premise, or there are multiple cloud service provider regions handling the replication in between. And then edge data stores are truly pushed all the way out to the edge. So a single region data store just looks exactly like this. And apologies to people who are not from the United States. It's really hard to find a more inclusive map. I tried Hyrule, but I couldn't get one in black and white. So we'll use the United States because there's a lot of contiguous white space. But just imagine this is wherever you're from, and there's all these POPs scattered around your country or your region, and you have one centralized database in the middle. The advantages of this is that it's simpler to provision. You've probably already done this in your company, in your operations, and you know how to do it. You have the muscle memory of running this. And from the replication perspective, it's simpler to operate, right? You don't have the replication concern that you need to address. It's also co-located with those assets that are there for workloads that are more closely aligned with single region workloads. If you have that example where most of your data is coming in from all over, but you're taking advantage of other managed services from a cloud service provider like Amazon Translate, Amazon Transcribe, et cetera, then this might be a good use case for you because the majority of your real work is happening in one place. The disadvantage, if you go back here, is hypothetically that database is in Iowa. If your workloads are out in Seattle and you're really latency sensitive, that might actually make a difference, and we'll look at some numbers here. The point isn't to read all of these numbers. The point is to show that in the US, you're looking at a mean latency of 15 milliseconds by using a single region data store if you just assume your traffic is perfectly weighted across those cities. Of course, the more actual reality is that your traffic isn't. It's pushed out to the coast where all your people live because that's what the workload looks like. So it gets a little bit closer to the 20s in terms of milliseconds. And this is just network latency, right? So it's not all the other parts of your workload. Some examples of this: AWS Aurora, the managed service by AWS, MongoDB, which offers self-hosted and a managed service, PlanetScale, who's here today, PostgreSQL that you manage yourself, and Xata, who's also here today. And I feel like I should point out that both PlanetScale and Xata are building multi-region currently. So if that is where your interests lie, you might want to have a talk with them. They're out here. A multi-region data store is what it sounds like. It pushes your data out to multiple regions of the cloud service provider, as we said. And it looks like this. And you see that those coastal workloads now are starting to get local copies of data to read and write from. So the latency really takes a step down, more to the single-digit millisecond for every place. The advantage of this is that you get more balanced latency across all of your users. Transactions are still available at this point. ACID transactions are part of some of the solutions in this category. And you have various consistency models that you can choose from. If eventual consistency is okay, you have options like that. If you need strong consistency in your workloads, even replicated across regions, you have options for that. The disadvantage here is that replication comes with a price. And that price is a mental workload of learning how to do it effectively and choosing a solution that enables it for you. It's the cost of having multiple copies of your data because you pay for storage and you pay for the network charge to send it to multiple locations. There's a complexity inherent in managing replication. And then again, if you need that strong consistency, you're going to have to choose a workload, or I'm sorry, a data storage layer that supports it, or you're going to have to build it in yourself. And that's not a trivial task, right? This is when you get into one of my favorite words to mispronounce, idempotence, or handling the same event multiple times with the same, without altering the outcome. You have to handle that yourself if you don't choose a data store that does that. And then again, transactions is on the disadvantage side as well because your favorite data store, when you take it multi-region, may no longer support transactions. This is the case with Amazon DynamoDB. You can have transactions or you can have multi-region, but you can't have both. But you can have DynamoDB global tables. So if you already know it and you're already building with it in your applications and you don't have those consistency restrictions, that's an option for you. Fauna is a solution, and I think the best one in this category. And so I would love to explain more to you about that. Please stop by and see me at the booth. That's not the point of this talk. And then Cloudflare Workers Durable Objects, which do not actually exist in all 275 points of presence, but look like that map that I showed you. They're pulled into a handful of geographical locations that are closer to the majority of where their traffic originates and where they have to deal with compute. So while Workers and Workers KV are pushed all the way out, durable objects aren't. They're pulled in just a little bit. And that brings us to the last category of data store, the edge data store. And this is where every edge POP has a data store associated with it. It's right there. So you see we have 9 on this slide. We have 9 cities that we're serving. That means we have 9 compute environments, but we also have 9 copies of our data. The advantages are latency. It's essentially 0 milliseconds in terms of observed latency, right? Because you're inside the data center, you're now down to the microsecond scale. It's a simple programming model that's unified with the provider. So you're not going across providers. If you look at a worker that consumes from workers KV, it looks like the rest of the code. It uses the same thing that secrets use. So it's a very integrated experience. And the security model is integrated as well. And we'll spend a few more slides talking about this in a minute. The disadvantages are there are only eventual consistency options at this stage. And if you think about what's involved in replicating 275 copies of the same data, that starts to make sense pretty immediately, why that is that way. And of course, for the same reasons, there are no transactions, right? You can't wait for all 275 to come to some sort of consensus, or your application would just be completely unperformant. And then the third is data visualization tooling, which is an opportunity for all you builders out there to build something. But it's how do you look at, show me all the items in my data store when you have 275 data stores in a meaningful, performant way, right? That's just not a problem that's really been solved well yet. Or if you think that's not true, please let me know so that I can learn and share it. I only know of one example of an edge data store, and it's a very good one, Cloudflare Workers KV. So if your constraints match that model, it's a very good choice. Look into it. Again, it's always going to be constraint and use case driven. So let's talk about authentication and security a little bit. Part of this comes out of that history that I told you of where this came from when you think about edge functions, and they came from CDN providers, not cloud service providers. But a typical application without workers or without edge functions would look more like this. You hand the authentication back to your data storage layer, and every request comes through, goes to the data storage layer, determines whether it should be allowed or not, completes, returns a response. And you can do this with edge data stores as well, but now keep in mind, wherever that data layer is, you're going back there on every request. So there's your trade-off. This is using a third-party service provider like Auth0, also here today. Stop by and say hi to them. And at this point, the trade-off here is that you may not need to go all the way back to your data layer, but you need to go to your IDP. So you need to understand what the latency impact of that is, and whether you can cache the lifetime of a token once you've seen it. How you manage that is largely going to be up to you. You can make it performant, but I don't really know of a solved way to do that out of the box where every request is authenticated without a round trip to the service provider. But the main point I want to make here is that these all came from CDN providers initially. And CDN providers are really good at detecting malicious traffic. That is happening in the same data center where your workers or edge functions are running, which means they are very, very good at determining if that traffic is malicious before it even gets to your function, which means they are very, very good at stopping it so that you don't have those invocations that then bleed down to further layers like your data storage layer, so that you get a lot of immediate protection and cost savings sort of built into these in a way that you wouldn't, where you would need to add a web application firewall or something similar to a classic application. So that's it. What did we learn? We learned what APIs at the edge are, how they differ from traditional serverless applications running in a single region. We learned when you should use them, what sort of workloads are good for them, when time is money, when latency is the key factor, when you shouldn't use them, if you have a bunch of big dependencies or you have already centrally located data. We learned how to choose a data store based on your requirements, what you're comfortable with, and how that supports your workload, and what some of those options are. And then we touched a little bit on the authentication piece and the security that's provided for the cloud service providers. Thank you. If you have any questions, that's me on Twitter. Thank you all for coming.
Keep it going, y'all! Woo! Thank you so much, Rob! Yeah! Awesome! All right, folks. So before we jump into our next talk, guess what I have to give away? The winner of our Planet Scale Photo Challenge is the proud new owner of a brand spanking new pair of Ray-Bans. We are going to be giving away our last prize of the day, so you better hope it's you. But the person who gets these stylish new sunglasses is Jeff Roseman. Where's Jeff? Jeff, hey, come on down, claim your prize. Give it up for Jeff, our Planet Scale photographer premier extraordinaire. Thank you. Enjoy, and may they keep the glare out of your eyes. Alrighty, and next up, Are you ready? That didn't sound like it. Okay, bye. Are you ready? Yeah! We have a principal software engineer at Liberty Mutual Insurance who is focused on serverless development and enablement, here to give what is surely going to be a very amusing talk about scaling serverless first. Please join me in welcoming to the stage Kristi Perreault.
Well, good afternoon, everyone. How are we feeling today? Awake? I hope so. Woo! Is anybody else as starstruck as I am by some of the awesome speakers we've had here the past couple days? Yeah, me too, right? Well, I'm super excited to be here. I'm Kristi Perreault. I am a principal software engineer at Liberty Mutual Insurance. And today I'm going to be talking a little bit about how we've scaled our serverless first initiative at Liberty Mutual. A couple housekeeping things before I get started. I will not be selling you insurance today. I will not be singing the Liberty Mutual jingle for you today. And no, I do not know the emu. So just a little background on us. So we're an insurance company. If you have not heard of us, we exist to help people embrace today and confidently pursue tomorrow. And we do that by promising protection for the unexpected delivered with care. We rank on the Fortune 100 list, and we are the 6th largest property and casualty insurer globally. We are across 30-ish countries and economies worldwide, and we have nearly 45,000 employees, with roughly 5,000 of those actually sitting in technology roles. So we like to say that we are a technology company that just so happens to sell insurance. So a little bit about me. I'm new to the speaker stage here. So as I mentioned, I'm a principal software engineer. I work in our serverless DevOps and enablement space. I've been with Liberty Mutual for about 5 years now, and I've been in the serverless space for roughly 2.5 years. As part of the March 2022 cohort, I joined the AWS Community Builder program in the serverless cohort. I've recently finished my master's degree in electrical and computer engineering, so I actually have a pretty robotics, hardware-heavy background in academia. I'm an East Coast native, born and raised, but I've been living in Boulder, Colorado for the past couple of years, where I am always outside. And I'm a huge proponent of women in technology. I work very closely with the Women Who Code chapter out in Denver and Boulder. Thank you. So quick raise of hands here. How many are pretty new to serverless? Like maybe you just decided to wake up today and come and check it out? Awesome. And how many of you would say like you're pretty familiar with serverless, you've been working with it for a little while, maybe like an expert in it? Okay, well you're all in the right place because we'll talk a little bit about both here. So I want to start off with defining what I mean by serverless. As was mentioned in the panel this morning, folks can have very different definitions of what serverless is and what it looks like. So in our case at Liberty Mutual, serverless is event-driven architecture. So this does not mean we're just lifting and shifting our architecture into the cloud. And it's also not just Lambda. I found that over the past couple of years, serverless has been really synonymous with this term Lambda. And although it's a large part of the ecosystem, it's not the entire amount of it. So you unfortunately cannot just slap a Lambda function on your project and call yourself serverless. I'm glad that is not the case because I would probably be out of a job if it was. No need to manage any of your servers. So if this is a big one for us. We no longer have to worry about physical servers. And I think in the time that I've been here, we've closed at least one major data center, which is awesome. And if you've caught our commercials, you know that our tagline is, you only pay for what you need. That happens to be one of the biggest selling points of serverless. So I'm happy to say that we are taking that to heart and using that to build out our technology. So when I say going forward in this presentation that we're embracing serverless first, it means that we're going to try all of these things first and then work our way back from it and down from there if serverless does not fit your use case. So our current state of serverless right now today we have a centralized sort of hub of patterns and development. So this is for serverless and for other types of patterns and processes. But this basically means, our claim to fame right now is that you can take an intern on their very first day, have them use one of these patterns, and be up and running in the cloud in production with a serverless application in less than 1 hour. So this has in turn led to really rapid community adoption of this, to the point where we're at, when I checked about 2 weeks ago, we have 70,000 Lambda functions and 5,000 API gateways across a couple hundred AWS accounts. So this is massive scale. And we were even recognized externally at AWS reInvent this past year as part of the CTO's keynote with an 8-minute time slot. So if you haven't checked that out yet, I highly recommend that you give that a watch. So obviously this did not happen overnight. We did not just wake up one day as a 109-year-old company and suddenly become serverless. So what did we do to get to this point? So this is where my team comes in and my role kind of plays a part here. So I'm on our serverless DevOps and enablement team. We're a small team of 4 that works to get these 5,000 or so technology employees embracing serverless first and moving to the cloud. So we have a number of different roles and responsibilities, some of which I have listed up here, and I'm going to actually go into more detail into each and every one of these things in the next couple of slides. But overall, we're here to build up and enable our serverless community. So the first one is the pattern development, as I mentioned. This is very community driven, so we let our developers come to us and tell us what they need and what they're looking to do. And they'll see and recognize the patterns that they're using most frequently and ones that they think that others can take advantage of. And they offer those up through this one-stop shop catalog of offerings where every developer can go in and pick and choose what they need to create. In our case, we have contributed a couple patterns ourselves, some really bare bones beginner CDK and SAM projects that have helped folks out. And as I mentioned, this helps to enable our developers on the very first day, on day 1. And it's really lowered the barrier of entry to serverless to be not this scary thing that they need to know absolutely everything about, but they can get started with it very quickly. Additionally, it's also provided us with a lot of metrics to see where the community is headed and what they're taking advantage most of. So for instance, I'm actually able to see that for most of our CDK patterns, all combined, we've had about 4,000 projects generated with the CDK. So every developer absolutely loves writing documentation. I definitely know this, right? So one of the major parts of our team is to write this documentation and keep it up to date for our developers. So I've kind of broken this into what we document and then how we surface that documentation. I won't spend too much time on this, I promise. It's not overly exciting. So what do we document? We document a lot of how-tos, maybe how to get started with serverless, how to get started with the CDK, how to add authentication to your serverless project. We do a lot of getting started guides as well, which kind of go hand in hand with the how-to guides. We do a lot of workshops. I keep referencing the CDK. It's one of our most popular tools at Liberty Mutual. So the CDK workshop is one of our really popular ones that a lot of folks like to take advantage of, and we've actually kind of libertyized it to be standards within our company. Any sort of examples, so code snippets or example projects and repositories, this is a huge learning tool and a way to document as well. And finally, if you haven't heard of the well-architected framework, this is a service provided by AWS that we take advantage of at Liberty Mutual as well. So we try to have our developers and our projects follow the well-architected framework. So we use that documentation to kind of follow along and build our applications in the most effective way possible. So how are we surfacing these things? Through a couple of different means. If you know me, you know that I love having the documentation as close to the code as possible. So I really love having robust READMEs that link out to all of these different things so that you have everything right there in one spot, easy to find, easy to read, and you're not spending your time digging for documentation. Your repository itself is a great documentation source. Code itself is kind of documentation in itself. Any sort of documentation hubs, so we like to use Wiki, we like to use Gitbook. There's a whole bunch of different resources out there to kind of further elaborate on things that might be bigger than a README. Any architecture or threat model diagrams, if you're in the cybersecurity space, this is another great thing to document and include in your applications. And finally, our patterns themselves have their own definition and kind of blurb with them that also links out to example projects and patterns and things. So our support model is another big piece of this. One of the key things is making sure that we're readily available for all of our developers. And I don't mean 24/7. If you're up at night at 2 a.m. wondering about your single table design, please don't call me. We mean kind of in the sense of in our Slack channels, in our Teams channels, any sort of communication channels, folks know who we are, how to get a hold of us. We include our contact information in all of our patterns and our resources, so we're easy to find. The nice part about that, though, is that we like to learn out in the open, so folks will ask a lot of questions in these channels, and then they'll kind of answer each other's questions, which is really awesome. So before I even get to answering something, sometimes there's 3 other responses already, or 3 other answers where they're using their knowledge sharing and they're providing reuse to each other. So for instance, I might see something like, hey, try to get my API gateway working, don't know how to do it, has anybody else experienced this? And there's 5 other responses from different teams across the company that have run into the same thing, and they share their projects and their repositories with each other, which is really promoting this concept of reuse. And finally, it is a 2-way street, so we do reach out to our serverless super users and ask for their feedback, see what we're doing well, see what we need to improve on, and then also share our product roadmap with them to make sure that we're all on the same page in terms of what they're looking to enable. So enabling constraints is another one. This is a very fine line to walk. I actually know one of the other talks this morning talked about removing constraints. As an insurance company, we do need to have some security practices and some secure things in mind when we're creating these applications. So we follow this set of security rules, which is an application that integrates with our CI/CD tools and flags certain resources at deploy time to let us know whether or not they're being created in the most secure way possible. So for instance, if you have a Lambda function and you're trying to push it out on an old version of Python, we're going to stop you and say that's not okay, and we're going to immediately delete your resource. So we do this with a number of different resources, serverless or not. And the other one that we really look out for is resource tagging. So we really need folks to tag their resources. This way we can kind of identify exactly where tech debt's occurring. We can identify exactly who is incurring cost and why. And we can reach out to these folks as well. And in certain cases too, if there's a security issue, like Log4j, we know exactly who's using Java Lambdas and who may be at risk for these kinds of things. Education is a key part as well, so we really want to focus on educating our technical leads. The first way to do this, and probably the most obvious way, is through training and workshops. So we highly encourage our architects, our tech leads, to go out and do this training, these workshops, whether it's on their own, whether it's taking classes, and just learning about it. We really encourage experimentation, so we want them to try new things. We have a sandbox account where they can POC projects, create MVPs, check out new services, beta test, kind of whatever they want to do. And this leads to them becoming examples to model. So we want those folks to go back to their teams and to help us out. As I mentioned, we're a small team of 4 trying to enable 5,000 engineers. We cannot do this on our own. So if we can get the tech leads and our architects kind of on board with this serverless first initiative, they can become the examples to model. We're also educating them in the well-architected review process so that they can work one-on-one with these teams to go through well-architected reviews. So this is probably my favorite part of working on this team, is working on our data-driven decisions. So we actually own a process that goes out into these hundreds of different AWS accounts and pulls back Lambda and API configuration data. So that is how I know we have 7,000 Lambda functions and 5,000 API gateways, is because of this process. And it helps us out with 3 different things: cost, tech debt, and security. So for tech debt, we can pull this data and say, hey, you have not invoked your Lambda function since 2018. probably not being in use. We can probably clean that up, and you don't need it around anymore. In terms of cost, we can see how much memory size you've configured. We can see if you're over-provisioned and if you're costing more money than you need to. This is kind of a funny one because you think serverless is pretty cheap. That's the cool thing about it, right? But when we have so many engineers and so many resources out there, that cheap cost really adds up over time. So if we can keep an eye on that tech debt and seeing how much we're spending, and the flip side of that is we can see where there's a spike in cost that may be kind of unusual or a bit of an outlier. And finally, again, security comes up in this as well. Like I said, I think they recently just announced that Python 3.6 was going to be deprecated. So this is a great way where if your resources are tagged, we can reach out to all of those people and make sure we're staying secure and up to date. So finally, all of these things really come together to create a robust serverless community. And I want to clarify that my team is not the community. We are just part of the community. So my job is a lot easier when folks can experiment, try things out, and they kind of gravitate towards the tooling and the resources that they like and they want to use, and can come back to us for help with enablement. So I want to just reiterate, like, we are not meant to be the community. We're not trying to force certain toolings or practices down to the community. We only want to be part of that community and be part of that voice. So obviously, we've been on stage at reInvent, so we're perfect, like every other DevOps organization out there, right? Not exactly. There are definitely areas where we still need to improve, and we're still kind of struggling in some spaces as well. First is with that day 2 development. So Jeremy actually set me up very nice for this morning. As I mentioned, back in the beginning, we'll go back to that example of our intern. So our interns here, day 1, super excited. They're up in production in a serverless application in the cloud. And then they turn to you and say, what now? And that's when you realize that they have no idea what they just deployed. Or the flip side of that is they deployed maybe a Lambda function, but they said, hey, I actually need a data storage, or I need a compute method that isn't this. They need X, Y, and Z. We gave them the bare bones, but they don't know how to build off of that. So it's come around to this question of, well, now I don't understand how this works. So this is really highlighting a clear education and knowledge gap that we're focused on this year. Along with that is the scaling of this education. So I did mention that we're educating our tech leads, which is great. But scaling it across the entire organization is a completely different animal. So the first is, how do we help everyone? There's 5,000 engineers. Some of them are really, really mature in serverless, and that's all they want to build. Others are still on-prem and haven't even touched the cloud yet. So there's this large knowledge gap that we need to work on filling, and there's not going to be a one-size-fits-all answer or solution. Going along with that, how do we centralize our tools and best practices? So one of the terms I've kind of coined over these past couple months is this idea of serverless silos. So we'll have a department way over here that has a group of folks that are really into serverless, and then a department way over here that has the same thing. They don't necessarily know about each other or communicate with each other that much because they don't have to on their day-to-day. But they could be running into some of the same issues and solutions and building out their own solutions to these problems that are very opinionated or specific for their group, when they could actually, in fact, be sharing it across each other, because we're finding that there's duplicate work coming out of this. So how do we centralize these tools and best practices without forcing everybody into one certain way to do something is another difficulty. And finally, how do we protect our teams? So as many of you probably know, you don't have all the time in the world to play around with cool things and cool tech. Sometimes there are teams that are working on building out features or on call or putting out fires all of the time. So how do we give all of these teams equal access to experimentation and innovation times? And cloud experimentation in itself is another difficulty. So like most companies, we started really small with AWS. We had maybe 3 accounts, and everybody started using them. Over time, they've gotten really, really bloated and kind of out of control. So we've since moved folks into team-level accounts as much as we can. But we still have these bloated accounts sitting out there, one of which, namely, is our sandbox account, which just about everyone uses for that cloud experimentation, and it has led to a number of cloud tech debt, as you can assume. So cleaning up these accounts and figuring out who's responsible for some of these things, especially our older resources have not necessarily been tagged appropriately, so we don't know who to reach out to or who owns that or what's in use still. Again, making the time for this is huge. Not every team has the luxury of having extra time. I know some groups that get to spend a week every couple months on innovation or a Friday afternoon, but that's not the case across all of our teams. And finally, sometimes you do get the chance to experiment and play with things, but you don't report out to everyone. Maybe you share it with your team, but it doesn't go beyond that, or you just say something along the lines of, oh, it didn't work, we're backing away from this, and there's no reasoning. So having more thorough report outs would really help others not duplicate this work, or the flip side of that, let a team like us know exactly what you need to be enabled. And finally, the buy-in from tech leadership is another big one. And I will say that we have buy-in for serverless for tech leadership, but this goes back to the beginning where we don't always understand exactly what the definition of serverless and what serverless first means. And trying to communicate that to the business side is a little difficult sometimes. Serverless is not a concrete product that you can hold in your hands like an AWS team that manages your governance in the platform. It's a little bit different, and it's a mindset shift. Again, it's not that idea of we're going to lift and shift your architecture. You have to rethink what you're doing and change your mindset to be that event-driven definition. So doing that and then making sure that we can prioritize the education and the work that's involved in that. So given all of this, the good, the bad, the ugly, kind of where we're headed for this year. So an optimal future state that I'm seeing is to kind of continue down this path that we're doing. First of all is to continue with this data collection and see where we need to invest our time and effort. So I've mentioned a lot about Lambda and API Gateway. There's obviously a ton more serverless resources out there. We're mostly an AWS shop, but we also support multi-cloud. So looking at some of that data and seeing where our time is best spent and what we need to enable is definitely on the horizon. Standardizing these processes, getting the right folks at the same table, and just talking about what tools and what processes we want to continue enabling going forward, and standardizing that as much as we can across the organization is also up there. Education is always going to be a theme, whether you're in serverless or not. We're in a community where education is key and important, and you do need to stay on top of the latest and greatest. So we're going to continue doing this and figuring out ways to scale our cloud education. And finally, the expansion. We want to make sure that we're going across all areas of our organization, from those that are really mature in serverless to those that may have not even heard of it yet. And we're hoping that all of these things combined is going to lead us to building up these empowered developers. My job is a lot easier when folks can come to me and tell me exactly what they want, where we can focus our time and energy. And then we have really empowered developers that make really awesome and creative solutions. So thank you very much for listening. That's all I have for you today. Feel free to give me a follow. Reach out to me with any questions you may have. Thank you so much.
Woo! Keep it going for Kristi, y'all. Yeah! All right. Folks, the moment has come. We are here. We have our last talk of the day and the week and the year, I guess. So closing things out today, here to help us look under the hood of serverless and appreciate all of the work it helps us not do, which is the great part. We have a amazing speaker. And in fact, since this is Dev Coachella, we're going to need to have our last final speaker get a special musical intro. So can y'all help me drop a beat here? Thank you. All right, get ready, folks, because this next speaker, well, you could call him Mr. Kumar, head of Xata Dev Relations, Every audience rages when he's tearing up stages. Give it up for Tejas! Woo!
Hello. How are we doing today? Great. I'm gonna need more than that. There's like 2 of you awake here. How are we doing today? Yeah. How are we doing today? All right, let's get this. As I was so lovingly introduced, my name is Tejas. That is pronounced like advantageous. Let me get my slides running here, and we should be seeing my thing on the screen. There we go. Okay, let's get this working. There we go. My name is Tejas. That's pronounced like advantageous. For those of you who don't quite get the exotic name, and I am the director of developer relations at a company called Xata. Or Zeta, we're working on it. We're a serverless database, and we're really a developer experience company, trying to give developers the best experience possible with databases, including being able to query them from the edge and so on. But that's not what we're here to talk about today. Today, we're here to talk about building massively scalable and performant Jamstack apps and serving them in a performant way. And of course, this is something that serverless allows us to do. Without serverless, this talk wouldn't exist, right? And the intention really today, or the motivation, is to appreciate that, is to look at how serverless helps us build these things and just kind of be in awe to sum up this conference. Can we get on board with that? Is that something we're wanting to do today? Please. Absolutely. So I have to say, the motivation here is not to build one of these apps, like as a demo and then load test it and have you be like, wow, that's amazing, and then leave here unchanged, right? That's not the goal. Like, that would be a huge flex, and you'd be like really impressed, but you'd walk away with nothing. Instead, the motivation here is education by demo, okay? Like, the way I learn, I went on Twitter some time ago and I tweeted this. A lot of people ask me how I learn stuff, and it's my job to learn stuff. I work in DevRel. The best way I found to learn stuff is to take stuff apart, is to build like low proof of concept style clones of things. So when I didn't understand the JavaScript library RxJS, what did I do? I built it from scratch by trying and failing. When I didn't understand React internals, what did I do? I built a cheap clone of React to understand how it works under the hood. So this is the way I learn. And what I want to do in our time together today, in our 25 minutes, maybe more, it's the last talk, so I'll try, is look at 3 ways that serverless helps us, 3 ways web apps benefit from serverless, and learn how they work under the hood, and save us from the work that we don't do anymore, and appreciate that about serverless, okay? Specifically, I want to look at, number one, I lost the connection to my slides. Hang on, let's go over here. What I want to look at is CDNs, how they work under the hood, and how the work they save us from. Number 2, serverless function runtimes, and how they work. And number 3, serverless databases. And I do appreciate some of the work that happened, some of the talks that happened earlier today about those things. And what we'll do is we'll look at them in maybe a hand-wavy way in 20 minutes, but in a way that will give us a rough idea and then help us understand the complexity we're saved from with serverless. So let's start talking about CDNs. CDNs are content delivery networks. And really the problem they solve is multiple. They help you load balance your app. They help you reach people quickly. But let's get into a quick diagram to get us all on the same page and then talk about some of their benefits. Up on the screen here, we have a tool called Xcaladra. I love it. It's great for diagramming. So essentially what CDNs do are, just for those of us who want to get up to the same speed, is if this is the world, let's draw some countries, right? So we have the USA. Excuse my Picasso skills here. We have South America, maybe. Dear Lord, I cannot draw. We have something that is slowly disappearing up here. Canada, Europe, an Eastern European country that shall not be named, some of Asia, Australia, and of course Africa. Okay, this is my 5th grade art project. Okay, so anyway, now if you've got an app, you have an app probably deployed on a server somewhere. Keep in mind, we're looking at what serverless saves us from. Serverless saves us from servers. It is serverless for us, and other people manage it. Okay, so your app is deployed here in the US West on a server somewhere, and you've got users. Let's use the teal color. I don't know how this looks on the screen. I hope it looks good. So you've got this teal color for your users. And what's going to happen is your users will send a request to your server to get some stuff. That is going to be quick if your users are in US West. But if your users, you get one day someone from like Australia wakes up in the middle of the ocean, apparently, and queries your app, what's going to happen is there's going to be like a ton of latency. This will take multiple, or like 100 plus milliseconds because of the distance, the geographical distance. So how do you make it faster for them? You essentially put a server closer to them, and then instead of making this long request, this happens, right? They talk to this, and then if you draw an edge between these CDN nodes, you get a content delivery network. That's an oversimplification, perhaps. We have 20 minutes, but this is generally how CDNs work and the problems they solve. So in preparing for this talk, I built one just to understand the complexity behind it. And I'd like to share that with you so that wherever you are, maybe you're a front-end developer who deploys stuff and wonders, we all kind of have something we can take away from this. So in my experience building a CDN and getting up to speed, what I needed to start with was a domain, actually. That is a domain. I just mean a domain. A domain, something.com. And what I needed to do was use a DNS server to resolve the domain name to an IP address. This is what happens when you visit, reactathon.com. That name is resolved to an IP address, usually by a domain name system server or DNS server. There's a way of resolving these called GeoDNS that will allow a single domain to resolve to multiple IP addresses, usually the closest one. And so a GeoDNS system or method of resolution would allow you to take thing.com here and resolve it to any number of IP addresses. So something like, oh, that's out of bounds. Oh, that's also out of bounds. Something like this maybe. That's for Africa. And then you could have another IP address for Asia, right? And other regions. And so a GeoDNS server will look at the geo IP, so the location of the incoming IP address, and then resolve it to a region that's closest to the requester's IP address. That's, in a nutshell, the work that is being done here. And it knows where the servers are using a database that contains the locations of IP addresses and so on and so forth. That's what it takes to run a CDN. Are there servers here? Yes. Do we manage them? No. The servers are a DNS server and your nodes, your CDN nodes. And so to recap, apart from the beautiful drawing that I did, this is the checklist that you'd kind of have to go through in order to build your own CMS and understand the complexity. You'd need a domain. You'd need a GeoDNS server. You'd need failover. So if one of your nodes on your DNS network doesn't work, you'd need to fail over to the root node. And you'd need to manage that yourself. This is actually, serverless solutions manage this for us most of the time. You'd need nodes themselves in your network to serve content from. You'd need orchestration. Since you're running multiple distributed systems, they'd need to share configuration. So there's tools called like Puppet, Chef, Ansible that will help you do this, like replicate configuration over these machines. And lastly, you'd actually need content to deliver on your content delivery network. With serverless, it's handled for us. How incredible. There's also something to be said for, this is usually used, by the way, for static content. There's something to be said for code execution, aka serverless functions. This is another amazing use case for serverless, where you execute code on someone else's machine. And serverless functions or functions as a service have given us developers, especially those of us who are more from a front-end background, have proven to be such a bigger gift. Why? Because they reduce server-full code into effectively like function exports. This is magic. Has anyone here used Netlify functions or Vercel functions? Yeah, what an experience, right? Like you export a function and then it just executes, runs to completion, can be replicated in an isolated environment so it's secure, and then it just serves a response. How does that work? Let's find out. So again, in preparing for this talk, just to appreciate Netlify functions, Vercel functions, etc., let's try and mimic what happens. So what they do, and by the way, all of this is super hand-wavy. It's a 20-minute talk, so if you expect more, it's your own fault. Let's try and emulate what happens when Netlify picks up a function that you export. So I have a directory here. I didn't want to do that. I want to open this in the editor. And we're just going to try and build that. So it's literally empty with node modules. We'll create a new file. We'll call it index.ts. This will be TypeScript. If that offends you, I'm sorry. Deal with it. So first thing we're going to do in our serverless emulation is import Express from Express. We're using TypeScript, as I said. That's just because what I'm familiar with. I hope you're able to follow along if you're more of a Go person. And yeah, this is serverless, but we're doing this. We're creating a server, and we're listening on port 3000. So let's try and emulate. So Netlify expects you to export a handler, and then it executes that in its runtime. So how would we do that? We'd use a route with a parameter. Let's call it function. We get the request and response. And so here's what we need to do. We need to get a function somewhere. We'll require, again, this is a poor man's Netlify functions, just to understand. From the local directory functions, Netlify would probably clone your repo or something. Rec.params.fn, and we'll do a named export handler by convention. So we'll get that function. We'll invoke that function by giving it context and a callback. What are those? Context, I don't know, what do we want to give this function? We want to give it the request body, so we'll do rec.body. We want to give it headers probably, so it can do stuff like authorization and so on. And what about the callback? The callback is how the function tells the runtime it's done and yields control. So we'll say for the callback, we'll take two parameters. We'll take response text to serve, which is a string, and we'll just take options, which can be anything, to be fair. Okay, and so what we'll do is we'll end the response with the response text that we're given. Okay, and we will use the options. Maybe we'll get a status code in the options. So if we do, we'll set the status. So we'll say res.status, and we'll do options.status code here. And maybe we'll get headers too, who knows? It can be anything. So if we get headers, we'll set them. We'll say for const header value of, we'll use object.entries here to turn it into a little dictionary. We'll do rec.headers, or rather options.headers, excuse me. Okay, and then we'll set them. So we'll do res.setHeader, header, and then, header, and then value as string. That looks good to me, just as a little emulate. Let's try and run it. So we'll do ts node, index.ts. I'm not logging anything, so I'm assuming it's listening here. And what we'll do is we'll make a function. We'll do functions/greet.ts. I'll export a handler. And as we gave it, we gave it context and callback, right? So context is any callback, just for the sake of simplicity, we'll just say there any. And let's do it. Let's do a callback. For the response text, I'll write some HTML. Hello, SIP, serverless in the park. Pre-code, and what I'll do is I'll just like JSON stringify the context I'm given, just to debug, right? Null2, and we'll close out our HTML stuff here. All right, and then maybe let's, just for fun, let's give it a status code and options to see if that works. And maybe a header, x fun true. Okay. Does it work though? Is this running? It is. So let's try and open localhost 3000/greet. Yeah, and it works. I've invoked a function, and thank you. So do you see what happens there? So from user land, you export a function, hand it off to a runtime. Runtime does stuff and serves it. And so that concern is abstracted to the serverless provider, a la Netlify, Vercel, whoever. This is also totally ephemeral and ideally stateless, so it can be done, cloned 100 times in scale, however. So that's technically what it takes to run a cheap functions environment, but let's talk a little bit more about this, because there's something to be said for performance here. Based on the CDN discussion, most functions historically have lived in like US East, like one region. And Rob, who did a talk just now about edge functions, is I think the next logical step. What running functions on the edge gives us the benefits of CDNs, that is speed, gives us those benefits while also allowing us to execute things relatively close to our users. How they work depends on your choice of vendor, so AWS Lambda or Cloudflare workers, but we do need to spend some time, I think, talking about engines and runtimes. Let's just, for the sake of definition to get us all on the same page, define what a runtime is, because I know I've spoken to people here and that may not be immediately obvious. A runtime is something that gives context to your code. That's it. So probably the most popular JavaScript runtime in the whole world is what? Is your web browser. It gives your JavaScript code context like window and document that you can use to make your web pages interactive. Another popular runtime, Node.js. It gives you things like child process and FS that allows you to interface with the system. That is a runtime. It gives context to your apps. An engine has one job: read, interpret, execute code in a performant way. So runtimes live on engines. Okay? The problem is Node.js as a runtime is not built like specifically for running serverless functions fast. It's built for a lot more things. Because of that, in a serverless functions use case, it can be a little bit slow. So Cloudflare has built their own runtime, different than Node.js, with the one job of giving you speed at the edge with serverless functions. And this is the appeal of Cloudflare workers. It's like it has one job: to make your serverless functions safe and fast. All right, let's wrap up with databases. So we talked about CDNs. We talked about functions. Are you still awake? If you are, make some noise. Yeah. Okay. I need to do that. It's the last talk, and some of you, I see you like. Anyway, okay. So databases. Let's talk about this. The problem with databases in a serverless world, and I've had this conversation like 500 times at my booth over the past 3 days, is that databases are often not just databases for the intents and purposes of your apps. What does that mean? To understand this, let's build a database service, like the kinds of things that serverless vendors offer. When I say databases on their own are not enough, here's what I mean. There's no error there. Okay, so let's start a database. What I want to do is start Postgres. So I'll use Docker, okay, and I'll run in a way that removes the container. I'll run Postgres. I'll expose an environment variable. I'll call it Postgres password, and I'll say my password is yes, right? And I'll run Postgres just like this. So now I have a database. It's ready to accept connections. But what? Like, I can't use this in my app. I need an API. I need some way to interface with this thing. A database for web apps is not enough on its own. I need some type of API. Okay, well, how do I do that? Let's kill this Postgres, and we'll start it again. But now I need a network between my database and whatever API I choose. So I'll do Docker network create, call it SF, whatever. So now I have a network. So I'll start Postgres again on my SF network. It's running. Now I can start up something that'll give me an API. Hasura is a sponsor here. They didn't pay me to do this. They should. But that's the easiest way to get an API on Postgres. What we'll do is we'll run Hasura. This is the long command that basically just points it to the Postgres I'm running. And yeah, we'll do this, but instead we'll change the network name to SF instead of lol. And this looks good. So what I'm going to do is I'm going to start Hasura. And this thing is going to now talk to the Postgres database and actually make it useful for a web application. And just like if I go to localhost 8080, I should, yeah, so it's starting the Hasura console. And with enough time, I'll have an API. So here, I have an API into my database. So I can go here, I can create tables, call my table hello, add an ID column. It's a type integer, primary key is ID, right? And I add a table. And now I can actually interact with my database. I can insert a row. And if I want to use it in my app, I can actually just query it here via GraphQL like that. So a database often isn't enough. But let's take this further. Let's draw a little diagram. And here's what I mean. So you have a database usually to begin with, right? But then you start hitting scale, and you need to like add RAM and disk space and SSDs, whatever. But that's not enough, and you need to horizontally scale. So you add a replica. OK, that's great. And then you have an API, which is probably also distributed. But you start hitting like performance problems because what? This conversation always happens. It's like Groundhog Day. I've had this conversation so many times where it's like, I think it's time to add Redis. Some type of in-memory cache to help read from memory, which is faster by design. So it kind of looks like this, where if it's a cache miss, Redis will query your database, but otherwise it's fast. And then as you scale, you grow, you accumulate lots of data, and then guess what? You need a search engine, right? Like anything at scale. So Reddit, Twitter, Instagram, whatever needs a search engine. Databases have search engines built in, but their one job is not search. So you'd need something more like dedicated, something like Elasticsearch, right? You'd need some type of queue to help you replicate your database, oh dear Lord, to help you replicate your database into Elasticsearch. You need to orchestrate all of these connections and manage them and so on. So look how complicated that is. This is what some of the best serverless databases in the world save us from, okay? There's a ton of considerations that go into creating a good database service. Here are some of them. NoSQL, MySQL, YourSQL, RSQL, these decisions need to be made. You need to think of an API, you need to think of caching, you need to think of migrations, which in and of themselves are painful and dangerous. The point I'm trying to make is these are other people's problems with serverless. They are not, technically I work at Xata, so they're my problem, but these are, if you're like if you have 10 months to build a dating app, I would be so sad for you if you spent 6 of them figuring out a database. Can you imagine? So serverless, the point I'm trying to make is, helps us get all of these benefits. High availability, branching at the database level, security, analytics, all of these things without thinking of them. And we can focus on building the apps we set out to build. I would be remiss, though, without acknowledging some of the limitations. The point of this talk is to give you a balanced viewpoint. And the limitations are these, right? When you choose to have a serverless database specifically, yes, you can sign agreements and contracts about data privacy as much as you want, but you don't know. You know what I'm saying? You don't have physical access to like the machines. So you have to be comfortable with that. You have to be comfortable with the idea of probably maybe getting locked in. Maybe won't happen. Like at Xata, we actually try really hard to give you a way to leave. Because we want to have a product that's so good that you don't use it unless you really want to. You know what I'm saying? So some vendors may lock you in. And you grow so dependent on them that it's hard to move petabytes, zettabytes of data off them. Okay? Data integrity is another one. If an undersea cable is cut and you don't have access to the infrastructure physically, you just don't know about availability. And of course, security. Like if you own the machine, if you have access to it right there, you can do all the bespoke security magic you want, and you know. So there's a lot of trust required for these kinds of things. All right, let's wrap up. Let's talk takeaways. Takeaway number 1, serverless is really just a manifestation of the 0-1 end problem, but in the data infrastructure space. If you're not familiar with this, as software engineers, generally we do things either 0 times or 1 time, and then we write a function if it's more than that, and reuse it in unit tests and make sure it's good. If you don't do that, I think you should. Serverless is like that. There's a lot of companies that build CDNs. They built 3, 4, 5, and they're like, you know what? You should start a company. Let's do this for other people so they can do their thing. Serverless, in a way, is that. And I like that. It encourages you to think in that way, to think in reproducible, reusable, tested solutions. Number 2, fundamentals are fun. Today we looked in whatever 20 minutes we have at some of the fundamentals. We looked at GeoDNS. We looked at edge networks. We looked at functions runtimes. We looked at V8 isolates. We looked at engines and stuff. It's fun, right? Sometimes some people can take the fun out of fundamentals. But I want to encourage, let's maybe look at those things when we have some time. We learn a lot and we understand how we can better do our jobs. And third, I think this is probably the biggest point I want to make today, other than, serverless is awesome, is serverless is not a misnomer. Like I've heard how many of you have heard the joke today that it's serverless, but there are servers? Haha. Yeah, I see your hand, man. I've heard this a lot, and I've heard people like trash talk serverless a bit, like, hey, but there's still servers. And people have said things like serverless is a lie. I don't think so. Serverless is not a misnomer. It's not a misnaming, because to you, a serverless thing is serverless. You don't manage servers. So I would say serverless is not really a misnomer. It's not a misnaming. It's actually true. You don't manage servers. What it is, though, I would say is this. Serverless is a guarantee. More than anything else, it's a guarantee that databases, if it's a serverless database, not your problem. You throw data at it, it works. Functions, runtimes, not your problem. Content delivery, not your problem. And so with that, I'd say serverless is more of a guarantee that allows you to build massively scalable and performant apps in minutes instead of months. And with that, I want to say thank you so much for having me and for letting me close out this conference today. Appreciate it.
Keep it going, y'all! Woo! Thank you so much, Tejas! Ow! Yeah. Folks, we did it! We met in person for a conference here in this gorgeous place. Thank you all so much. And we have a lot of thank yous to give because there have been a lot of folks involved in making this happen. Can we first please give it up for 3 days worth of amazing talks from our awesome speakers. Please give them all a huge round of applause. Thank you all so much for the bombs of knowledge you've dropped on us and for just having such great conversations the whole time, inspired by these wonderful talks. We also, of course, need to thank our amazing sponsors for paying for all this. So please join me in thanking our presenting sponsor, Vercel. Yay, Vercel! And I hope everyone got to spend some awesome time with their staff at the booth the last few days. Also, please give it up for my amazing teammates at Hasura, our platinum sponsor. Yeah, woo! And again, hope you all got some good FaceTime in at the Hasura booth too. Thank you to all of our amazing sponsors. We've had contests, we've had snacks, we've had parties, we've had all kinds of good stuff that we could not have done, to say nothing of the amazing swag we're all going home with. Am I right? Am I right? So thank you so much to all our sponsors. And of course, y'all, you have been seeing and listening to an amazing production here today. And that is all thanks to the amazing staff that have been helping us behind the scenes and running around the venue, just making everything run so smoothly. So please join me in thanking our crew from Argus Video Production, the CalShake staff, the Reactathon volunteers, the Lifted Plate Catering staff. Please give it up for all of our amazing crew members. Thank you all so much. This has been such a great experience because of your hard work. And of course, you all are here with us in 3 dimensions so that we can talk and stand in Pac-Man semicircles and exchange great ideas and get to know each other, put faces with Twitter handles, and just generally have amazing conversations the last few days. So thank you all so much. Without you all, we would not be having a conference here. So please give it up for yourselves. Yeah! Woo! Oh, man.
If I might interject here, I think we can all give a big warm round of applause for our Masters of Ceremonies, Anjana Vakil.
Thank you so much. Thank you. Thank you.
Not only has she brought so much energy to the stage over 3 days, you have no idea what she's doing in the back there to keep us all together. It's been absolutely astounding. It's been a pleasure working with you, watching you work, and keeping me honest. It's been really great, really great.
Thank you so much. And please, everybody, please join me in also thanking the man with the magic plan behind the whole thing. Please join me in thanking our main organizer and host, Benjamin Dudby. Woo! Awesome. Thank you so much, Ben.
Thank you all.
Thank you, and thank you all for being here. I've been having a wonderful time. I hope everyone has as well. We are not entirely done here. We are going to wrap up the stage for the day. The sponsor booths are wrapped up for the day, but you are all welcome to hang out in this gorgeous venue. Again, thank you. Huge thank you to CalShakes for having us. We are going to be able to hang out here until about 4:30. You'll want to, if you want to keep the conversations going and keep the wasps shooed away, you'll want to head past the sponsor areas to the Lower Grove picnic tables. We are welcome to hang out there until 4:30. Or if you'd like, the shuttle is running, so if you'd like to head back, we are all going to gather later for the after party at the Graduate Berkeley from 5 to 8 p.m. So we will hopefully see y'all down there, and hopefully we will be able to see each other all again next year. So thank you all so much. It's been amazing. We'll see you next time. Bye, folks.